Welcome back to day two for the NRRA Conference. Hopefully everyone had a good evening. We had good times at Surly last night for a few of us that were there. So it's good that the Wild won, and it was bad that the Wolves lost last night. And if you could tell, I'm a little teary-eyed. It's because I like hockey too much. So that's the problem with that. So today we have updates from the teams on current projects that they're working on. So we'll start out with the ICT, go to the flexible and the geotechnical before our break this morning. So with little ado, our friend Kyle.
All right. Thanks, Ben. Yeah, like I warned you yesterday, you do have one presentation, just a short one, 10-minute presentation on what we're doing with DPS, which is dielectric profiling system, and we use it for assessment of asphalt density. And it is, as Ben said, also an ICT team overview, but we like to take this opportunity when we have a larger group to have like a fire hose of information that we shoot at you guys with all our fancy ICT stuff. So we're also going to have two projects, 10-minute presentations by Soheil as well. So just to point out here, one of the things I wanted to highlight today, since last time I talked to this group, there's been a lot of development on the, I guess, vendor side of things and industry, where we have a lot more options for deployment now. So I'm going to talk a little bit about what you see on the lower right, which is we got out on the first project this year, which is the Contour 3D DPS, we're calling it. And then in the upper left, and then also in the upper middle, you see that we're starting to get this DPS going on roller mounted systems. So just going to briefly touch on some of these developments. And I did want to mention that, you know, these are some of the presentations that we've done as part of our monthly meetings, and also really appreciate that we're starting to do those joint quarterly meetings, because I think that's what's important for our ICT group, is making sure the larger paving audience is aware of what the latest and greatest is. So appreciate the NRRA for allowing us to do that. So one project I wanted to highlight here was with the use of this new 3D Contour DPS, and it's the same system, 3D radar system that's used for a lot of other applications, but the manufacturer has got it to the point where we can actually use it to directly map the relative density on projects. So there was a really good candidate here where it was night paving. It was a big project, and the only way we could get DPS data was using this system as compared to the cart-based system that we typically put out on projects. And it was a big project. And the other thing here is, I don't know if it was Dave Van Dusen's fault, or probably. Okay. We decided we were going to go no vibratory roller compaction, and we're going to waive any disincentives and expect to get a good product out there. So I don't know, but no, I'm kidding. So that is true, but we did it for a reason, because of the conditions out there, which I won't go into the details now. You can talk to Dave about that. But because of that, we wanted to have some sort of assurance that beyond just the cores we were using for incentive, that we were getting consistency out there. So that's kind of where we pulled in the DPS as a quality management tool. Just briefly, it's really important with DPS in general, and especially on projects like this, the keeping track of where you're collecting. And so in this case, we basically just went out there and did a pass on the left side of the road, and then on the right side of the road, and that gave us a map with the 3D DPS. And so So the main thing we tried to do with this was to identify inconsistent areas, try to figure out where the anomalies are. And to my surprise, there really wasn't. It was a really, really consistent project. So I guess maybe Dave knows what he's doing. So, but we did want to investigate some of these areas where we did see some anomalies with the DPS. So what you see on the left there is the 3D radar map, where when it turns blue up there, that means we're seeing a little bit of a dip in density. But we also had other ICT technology out there that we could confirm that there was actually a construction reason for that inconsistency. So in this case, that actually gave us a little bit of confidence in this.
I think you're all wrong.
Oh, okay. We're going to cater to the online people, even if they didn't make the effort to get here with us. I woke up salty this morning. I'm sorry. The Timberwolves lost. It was a late night. Yeah. High percentage. There you go. I was trying to make fun of Dave, but he's too good of an engineer, and it ended up being a good project. So now I got to admit that. Looking at the very few inconsistencies that we did have, and comparing it with the other ICT, really what we were seeing is whenever we had some sort of a low spot or inconsistency, typically on this project, it was caused by they had to pull the paver and go do some turn lanes or things of that nature. So we give that feedback to the contractor. But the big story here was, despite no vibratory roller compacting and no disincentive for the contractor, they did a really, really good job. And I think part of that was, I think we specified 3 pneumatic rollers. Is that right, Dave? Something like that on the project. There's 3 pneumatic rollers on that one, Greg? Okay, Greg says yes. So anyway, whatever they were doing out there worked out really well. So this is an example, lower area, and they're still hitting 94% GMM. So, and the good news here is, with just cores, we wouldn't have really known if it was a consistent project or not, even though we were doing some non-standard things. So it was good to get that out there. This is a comparison of 3D DPS with our more conventional 9 passes that we do with 9 sensor passes with 3 cart passes with our cart-based system. And you can see here, this is just the center line. So this is 2 lanes where you see the drop in density on the unconfined side. And it's really showing the same picture, just maybe a little bit higher definition on the left there with sensors every 3 inches instead of every foot and a half. So, but with this, one of the good steps that we've taken is, you can take this distribution and get a lot of information out of it. But because we know air has a dielectric constant of 1, and that's not going to change no matter what project you're on, we've came up with a consistency measure where basically we can set a threshold for how much of a drop in density we're willing to handle on these 150-foot sublots, and use that as kind of a means of trying to go beyond these cores every 500 tons or so, and give us a little bit more confidence in the product we're putting out there. So with that, I did want to just briefly touch on another, one of the recent developments is getting the DPS sensor on the roller compactor, because it's great to have quality assurance after the fact, but if we can start to use this as a quality control tool, then we can start to build it right in the first place. And we started to look at this, and the initial results look good, just comparing on the top, the cart sublots with the variability measure, and then comparing that to the roller compacted, or the DPS on the roller compactor. You see a similar trend, which is good to see, and we're going to test that out more, which is good timing, because now we have, let me minimize this quick. We just kicked off our phase two DPS pooled fund. We have 16 agencies, and we're going to tackle this. And it was mostly research in the first phase, but now we're really going to go heavy on the ghost implementations, where basically participating states, we're going to get this technology out there and see if we can improve on our current state of the practice for evaluating density. Yeah, but with that, if I can advance to the next slide, I'll take any questions before we bring up Soheil. Yeah. No. So one of the question was, do we use this on all projects now? And I think the main reason we don't have it on all of our projects now is the deployment of it, which makes me really excited about the roller mounted system, because right now you have to either have somebody pushing that cart, or you have to have somebody coming in with a vehicle and a 3D radar system or something like that. But if we can get it on the roller and show that that's actually getting us a good variability measure, I think it's just a matter of time before that happens. So, all right. So I don't want to take time from Soheil, because I told him he had a half hour per presentation initially, but then now he had to cut it down to 10 minutes per presentation. So only the best part of his presentation is going to be today. All right, welcome, Soheil.
Sure. Good morning again. And can I borrow your tie or no?
Yeah, sure.
Okay. It's a pleasure to be here, and we have been in this business for a long time. NDT just started picking up in the United States, at least in the 70s, and I guess Sharp was in the 80s was when it became popular. This is a study just trying to see what's the best use of it, how we can do it, and what are the limitations of the equipment, what do you usually really need, you know? How much do you have to get from the device to change the thickness by half an inch, for instance? You know? If it doesn't change the thickness by half an inch, is it worth it to get very, very precise and spend hours and hours? So that's where this project started over. So the goal was to establish. Thank you so much. Okay. The goal was to find the probability of success of detection of different entities, you know. Doesn't matter what it is. And as a pre-design tool, this is not the payment management or anything. This is pre-design, you know, how we can help the designer to improve. And the second one is just basically put a guideline on what NDT to deploy for what problem. You know, that's what NDT is most sensitive to, problem that the designer is trying to solve. So we are looking at the capability and sensitivity. Essentially, what's the extent of defects it has to be before you can see it with a given NDT. You know, just if you are interested in initiation of debonding, can you get it? Or if it's totally stripped, can you get it? You know, and so on and so. There are different tools for different aspects of that. And the accuracy of prediction on the pavement design. You know, hey, a lot of the calibration that we do for the different pavement design, we are going straight to distress. We're never certain if you are getting the strains that you're using in the mechanistic correctly before we go to the next step. So if the calibration can be a two-step, then you know how good your software is, and then you can know how good is your NDTs, and then can you predict the distresses better. Anyway, so I'm going to go Federal Express type of guy from now on because of the time limitation. Huh? I don't know what happened, but you know, everything I pushed, it just goes back and wakes those guys up.
Here we go.
Okay. So the process that we're just trying to do, just basically what are the damage modes of interest to the community, you know? So what are the most prevalent problems that you have? What's the deterioration process, just to see what happens and when happens and so on and so forth before you start getting the alligator cracking on the surface, you know? How we can measure this deterioration indicators and how we can go and start monitoring the pavement to see when these are happening. And then, so essentially we just try to catch the problem as soon as we can. That the device is helping us, not before we see it on the ground and sending it. The two blue ones are the tough ones. One is the thresholds for each parameter, and then determining if existing technology can do it or what the technology has to do to get better and better. Okay, so I just go very quickly. So you select the damage mode of interest. Over here, I'm just going to go with fatigue cracking because it's easy. Everybody is designing for. We just go. We can use any equation that you use. We chose to go with the 10-37 equations, you know, MEPDG, Pavement ME equations, and look at it carefully and see what parameters you have. See how these parameters affect. So if you look at that equation, there are a bunch of factors that we don't touch. There are one thing that you have to do. You have to have the effective air voids and the AC content. You have to know that you can do it in the laboratory or with the cart or whatever. There are two things that we have to model. This tensile strain and the damage index that you saw in the equation. And there are only two things that you have to measure. One is the thickness of the layers. The other one is the moduli of the layers. And how we're going to do that. So to just simplify it at this moment, to get the thickness, the state of the practice is GPR or coring. And we are not aware of any state of the art coming in that area that we don't have. But the layer moduli, the state of the practice is FWD, and the state of the art is TSD, the traffic speed deflectometer. So we are looking at this thing, and basically we go through a sensitivity analysis, a Monte Carlo simulation, and something called the impact chart that we're going to use to see what parameter is the most sensitive one in your design. What parameter affects your design the most? Let's focus on that. If the thickness of the base doesn't impact your results for this to affect, don't worry about it. But the thickness of the asphalt maybe. And then we send a survey to the states, and we were very happy. 31 states answered. That's amazing. Thank you. And we started looking at the main devices that the states are interested, and it was GPR, TSD, and FWD. That came up, and then there were 20 other ones that, you know, we tried to focus on the top three over there. The distresses that the 31 states, you see that there are, excuse me, 31 of them, all 31 of them cracking is a problem. You know, it's just very amazing. And then delamination, debonding is the second one, and moisture-induced damage, the third one, and rotting was the last. So we are focusing on those. And then properties and conditions that are interested in detecting the loss of support totally in the pavement, find the weak layer, the layer thicknesses, and the delamination debonding. Those were the characteristics that we are focusing on. So I'm going to skip these because these are just for the 30-minute discussion. And we are right now developing a test plan to go with those three devices and the 4 defects. And hopefully in the next time, we're going to give you some advice. So now let's go to the next one. Sorry to be the Federal Expressman. You know, I was happily sitting in my room and then send an email with the news, the schedule. And we realized that there are 3 groups in 1 hour and a half in one group.
Right. Okay, let me do the special hide.
Yeah, sure. Just a question: how many of the audience know what the traffic speed deflectometer is? I'm hoping all the hands are up, right? So this is essentially EOP showed it yesterday. It's a device that goes at the traffic speed and collect the.
You can come back here.
Okay, thank you. Collects the deflection parameters from the ground. There are two of them right now in the United States. One is made by the Measure, and the other one is the Greenwood. Both of them are Danish. They're like 20 minutes away from each other. And there is a third one that is in Europe, the Dynatest one, the Raptor. We haven't seen in the United States yet. So the one that is right now prevalent is the TSD, the Greenwood system, because that's essentially. So we're going to focus on that. And I just have a lot of thank you from everybody that, that they were so worried about us that, to see how many people they put in the tab, right? No, actually, these are very interested. And EOP, thank you for your help. And I have a dream team on my side that, we are just having a lot of fun with this project. So what's the goal of that project is just to put it roughly, is around $45,000 to $50,000 a day to collect data, which is worth every penny of it. But what can we focus it to where we're going to get the most information out of it? Out of the system, right? So we are trying to maximize the information extracted, both at the network level and the project level. Right now, it's predominantly network level. We are hoping to get into the project level and minimize the cost of data collection and just give some recommendations to the developers of the TSD, how we can reconfigure the device, how we can improve the accuracy and things like that to do the other things that we would like to do that we cannot do right now. So the focus is between the TSD capabilities and our desire to what we are trying to do with it. So we found, can I put these guys? It's fine? Okay, good. Okay, so we found four uses for this device. The first one is essentially we do statistics. It just basically, you just run the device and see what the anomaly is. It just basically give you a parameter. You just basically do statistics and say, this is bad, this is good. That's great for network level. The other one is the overall pavement capacity. And that's when they come up with some indices from the parameters that they're measuring, and then they correlate those indices to different. And this one mostly is spatial and temporal data. If you have several years, you can start working with. And the third one is the project level. We just started touching it at the project level over there, and we're just trying to do structural capacity. So that's where the pavement engineering comes in. Before they were mostly the statistics and indices. And then load efficiency, that has been something recently came up for the rigid pavements, is doing. Our goal is to see, can you use it for other, except finding if the joints are bad or good. So to do these four, we just have a certain parameters that we have to look at from the accuracy. If you just want to see good and bad, you really don't need an accurate measurement. You need a precise measurement, over the. But if you are just trying to do project level, you need extremely high accuracy and precision, and you see that there are 10 criteria that we are looking at it, and we map it on each of the four applications. Again, a survey, and basically what we see that network level is a prevalent, project level 17 says both, but there are very limited use, but it's there. is coming. Main interest again, I don't know, fascination with delamination and debonding. I guess that's what we see all the time. Joint condition in concrete, weak layers within the structure and loss of structural capacity. You see that there's similarity between this and the previous one. They're the same. These are different groups and the same thing. The gap analysis based on the survey that we got, we did the gap analysis, and they are based on 3: data collection and processing, network level application, and project level application. What are the gaps in these 3 groups? I had nice slides, but I'm not going to show it to you. Okay. There are some caveats. I'm going to show you a little bit. These are not our opinion. These are your opinion. Okay. We are just, I guess some people started shooting at the piano player. I'm the piano player. I'm just summarizing what the DOT said. And then some of them are are issues that gaps because it's a new technology. Any new technology takes forever. I don't know how many years you have been working on the forever. Yeah, exactly. And there is a lot of intense research, a lot of experience, and then there are some problems that common to all NDTs. It's not unique to this one, but nevertheless, we started doing a SWOT analysis, and I saw we are running out of time. So essentially the strength is that, you can collect a lot of data. Now we collect data at 50 millimeter, 2-inch data. And you don't need the traffic control. There is the opportunity is to reconfigure the sensors and things like that so that you can get on a more precise data on the stiffer pavements at this moment. The weaknesses is that as the pavement right now gets stiffer, there is less precision, there is more noise in the data, and how we can improve that. And the threats is just basically complexity of the data and the database management. You get gigabytes of data, in one day. They do 200, 300 miles a day. You have to do the data management. So for this study, we have a golden opportunity. In 2021, we came and drove Ben and all the other staff, the research nuts for 2 weeks. We just did some instrumentation over here, and we got ground truth while the TSD was going over there. So we call these 6 sites that starts from the HMA, softest HMA, all the way to very stout, rigid pavement. We have what the signature as the truck is going would look like, and we are using those to deeply study all the issues that we are considering, and people are interested. So this is an example. We have sensors embedded in the concrete, and then we just look at the measurement of the TSD and the sensors. And this is a weak one. The data is good. If I show you a stiff one, it may not look as good as this one. And then we use the rest of the test sections to just validate what we found from the deep ones, because there are different thicknesses, different configuration, different level of distress, and so on and so forth. We are lucky enough we have data from 2019, 2021, and 2025. So we got vertical. We can see the progression of the deterioration on the sections that they have been there. We did some consideration of the different parameters, how they impact the measurements that you do. And you see that the thickness of the base, for instance, is not the big deal. Maybe the AC, you may want to run your GPR and get a good indication of the thickness. And the GPR is integrated in the DSD. Pavement, the moduli of the different layers, basically is sensitive to the sensors close to the tire is sensitive, the base as well, and then subgrade modulus is the strongest indication. So you get a very good indication of the subgrade modulus. So if you want to see what the subgrades, you get good information, but not as good for the other layers. We finally look at 46 indices that people have used in the last 10 years for this one, and these are the top 5 for each one of them. And the criteria we have for the best one is just a very strong correlation to one parameter. deterioration of asphalt base or subgrade and not being impacted by the other parameters when we do it. And again, this would be 30 minutes by itself, right? Okay. And so right now we are, the highest priority that we have is the network level, how to manage the variability and how to interpret the data so that you get the best information. The second priority is the project level. And then the first one is statistics. We are not going to touch it, the first goal. And the last one is just basically, we're going to run out of time before we get to it. So with that, I'm done. Sorry if I ran long.
Any questions for Soheil?
Yes, sir.
Yeah. So is that meaning in terms of like integration with asset management models and stuff like that, or is that part for the horse?
That was one of the opportunities, that how we can get the functional that we collect very regularly. We just structure. But that's one of the opportunities that I didn't get the time to go through all of it. But that's a great idea. You know, now we're going to have the functional and the structural, we can combine it together to make it a better job. Yes, we have to do.
I brought it up for our asset management policy, and one piece of feedback that I got for the consider was, to monitor the same road with time, just like they have for their given condition models. So you can see the relationship between the structure and the given condition for the same structured roadway over many years. So that they said they just did the switch to technology, but
That's also okay. Time. Yeah, we are fortunate enough. We have three. We're gonna have three periods every 2 years, 3 years. So that actually deterioration model you need time. And you want to make sure that it's consistent. So you know, if the pavement is getting quicker, you want to get more replacement. So you want to make sure that you're not accurate. Yeah. But that's great.
all right. Let's thank Soheil.
One, and so we're gonna have in a few minutes, we're gonna hear from Michael Vrtis here, and he's going to highlight one of our upcoming research projects called Perpetual Pavements and Wet Freeze Climates. But before we hear from Michael, I'm just going to give a brief update of what the Flexible team has been working on here in the last year. So maybe. Okay. So for those of you who maybe are new and don't know a lot about the Flexible team, so we're comprised of technical experts in the field of new and rehabilitation of asphalt pavements. So a lot of the things we do are, prioritize long and short-term research, develop test sections, long-term test sections at MnDOT and other locations. And we also, once we have that knowledge, we like to, work with the technology transfer team as well. And then also we want to focus heavily on implementation of the completed research. So we have about 25 projects now on our website, excuse me. And they're all under the 4 categories here that I have on the right here. So we have about, within the 25 there, we have about maybe, I think around 10 completed projects. And also we have a couple of projects that were completed that were extended. The test sections, they both had test sections. So we wanted to continue to, evaluate the test sections for the performance. We also co-sponsor research projects with other teams like the preventative maintenance and then ICT teams as well. And we have we have exclusively flexible projects. So we have about 7 ongoing projects in different, progression of their completion. And also we have a couple that are in the development stage now and RFP stage. So one of the things we did this last year was there was some available funding funding became available, $100,000 per team. And so it was sort of left up to the teams how they wanted to, have some latitude in how to, solicit proposals for them. So the flexible team took a kind of a similar approach of the call for innovation we had a couple of years ago there. And so if we recall, then we actually solicited needs from the agencies, and once we got the needs, then we forwarded them to the associate members, and then they come up with proposals. But in this case, we sort of skipped that first step, and we just solicited all the members for proposals. And so once we got the proposals in, we sent them out to the voting members of the agencies, and we asked them to pick the top 3. And so once we got all that information in, then we submitted to the executive committee. And so when it was all done, we had 14 proposals that were submitted, flexible team proposals. And sadly, we could only, fund one of them because of the available money. But every one of them every one of the proposals were really good. So thank you to all who submitted proposals. That was very good. They were all really good. So the one that got picked was the spray on rejuvenators 3-year analysis from Raquel Pochelski from NCAT. So congratulations, Raquel. And so we look forward to working with you. And we're also co-sponsoring that with the preventative maintenance team as well. So besides the research and the nice great conference we're having here, a significant part is our monthly meetings. And this year we changed it up a bit with we have joint meetings with all the teams, or quarterly meetings, and I think they're working out really good. And so the meetings though that we have just exclusively with the flexible team, we try to concentrate on, we have a lot of good general updates, and then we have always try to have a presentation of some sort, maybe 10 to 15 minutes. And then we've tried to integrate more discussion into it to allow some time so that we can have a little more interaction and things. And so a lot of the topics I have up here, I'm not going to go through them all, but actually a lot of our discussions are really good, and sometimes they turn into presentations or even maybe possible research. So that's working good. So I put a slide in here at implementation because, coming from an agency, I'm really excited about all the stuff we're doing that's been completed and ongoing and developing. I think we're going to have a lot of stuff and we do now. We have a lot of stuff we can take back to the agencies to implement. We're going to have, not too distant future, we're going to have, tools for overlay, for reflective cracking, so we can figure out what mixes and additives to use to resist reflective cracking and thermal cracking, guides for perpetual pavement design and construction of them. Balanced mix design. Balanced mix design is kind of through the whole thing here. It kind of relates to everything we're doing, and being able to account for the aging of the mix and the warm mix technologies, recycling agents, having a guide for recycling agents and rejuvenators, being able to figure out how much effective binder we have in the wrap, and cold asphalt technologies, ways to make our joints and rumble strips more durable and better milling, capabilities. So we got a lot of stuff we can take back because it's all directly related to the agencies, all this research. And, so anyway, I want to thank all the members for all your hard work and diligence through the year, and all the technical teams that are on all these research projects as well. And I want to thank the executive committee and Ben and Curt and Mark for all their leadership and guidance, and Lauren for coordinating all that we do, and making our website so easy to get through. And Michael, I want to thank you for all your assistance in my chair duties. So, and from that, I'm going to get Michael going here. So Michael Vrtis is the Assistant MnROAD Operations Engineer, and he's going to be talking about perpetual pavement test sections and wet freeze funds. So welcome, Michael.
And Curt, thank you for all this.
Good morning, everyone. Thanks for joining me for another Pavement Nerd therapy session. I'll try to be relatively quick this morning, get us back on schedule. Really, the takeaways from my presentation today, remind everyone what a perpetual pavement is, and then the cool test sections that we built at MnROAD, as well as in Wisconsin and the partnership with WSDOT that we have with this project. So this is my only AI image that I have in this presentation. So sorry to build up yesterday and then disappoint with this one, but I asked Google Gemini to draw a road that lasts forever. So apparently we just need to paint our roads with some rainbow metallic colors and they'll last forever. No, just like I said, the whole point of this presentation is to renew interest in this project and solicit participation in the TAP. When Curt and I put this agenda together and we're working with the Flexible team 3 or 4 months ago, the intention was that we would put this project on the agenda and it would force MnDOT and me to focus on it, get the RFP out, and get the project rolling again. But as you guys saw in my slides yesterday, I've spent the last month doing asphalt chemistry and playing with cereal and noodles and all that kind of stuff. So we don't have this RFP out, but we will be releasing it in the near future and getting it rolling this summer. So in general, what is perpetual pavement? This isn't a new concept. There's been kind of full depth or deep strength asphalts for a long time. And then going through the literature, you start to see the term perpetual pavement start to appear in the early 90s. Especially for us here in Minnesota, you can't really talk about perpetual pavements, and even nationally in the US as well, without mentioning Dr. Newcomb and his work here at the University of Minnesota, and then as he moved on with NAPA and then TTI. But again, his first paper from 2001, the first line is, the concept is not anything new. So digging a little deeper into some of Dave's work, it really is designed and built to last 50 years with only a slight maintenance every 20 years from the surface itself. And this is accomplished in multiple aspects of the project, being material selection, mix design, structural design, and performance testing. So this is one of the famous images for a perpetual pavement. So these top lifts here above the blue are your asphalt layers. These are the different layers, and each one is designed individually to handle the stresses at that layer. So on top, you have a high quality surface. In the middle, you have a stiffer kind of rut resistant mix. And then a bottom, a rich or a fatigue resistant mix that can handle the repetitive strain at the bottom of the asphalt pavement. Additional to that, the work, there is a cap on the upper limit of kind of asphalt pavement or thicknesses that you need. Once we get thicker than this, you're really not getting a benefit. I want to point out these thicknesses, especially for the Minneapolis region. It goes anywhere from 7.5 inches of asphalt to 12.5 inches, and you'll see how that kind of plays into the sections that we built. So the sections that we built in 2022 with our MnROAD mainline reconstruction, we built 2 perpetual pavement sections at MnROAD. And then the following fall, we built 2 more perpetual sections, or we instrumented 2 sections that WSDOT built on I-94 in Osseo, Wisconsin. Osseo is about 2 hours east of here on I-94, just under 2 hours. So it's close enough that we can go with our MnROAD team and do regular monitoring and data collection there. But it's also the same stream of traffic with those sections as well. So we have the same instrumentation in different structures in different states with this. And then our MnROAD team is collecting the data. So the MnROAD section, we have 8.5 inches total asphalt. over 9.5 inches of base. The other sections that we built at MnRoad that year that Ishan talked about yesterday are 6 inches of asphalt over 12 inches of base. So all we did in the design here was change going from 6 inches to 8.5 inches and then trimmed the base up a little bit. So we have a nice kind of thickness comparison set up with those sections. Individual mixes selected. I'm not going to get too much detail on this for the sake of time, but the general concept of a high quality surface, we used an ultra thin bonded wearing course for the MnRoad sections. And then for the stiffer layer, we increased the wrap content on that middle lift. And then the bottom layer, we added 0.5% extra binder to give us a little extra flexibility on that bottom layer. So all of these tweaks were done within the contract, within the special provisions themselves. We didn't get any pushback from CS McCrossin, the mix designer or the contractor, as far as making these with the small additional wrap tweaks or additional asphalt contents. It's not going to be a perpetual pavement if it's not constructed properly. Really got to emphasize the importance of using all the tools that we do for construction. Just because with a perpetual pavement, you need it to last a lot longer. So any little flaw that you have is going to be amplified over time. So you got to get it right on the first time. So construction quality is very important. And then our routine performance monitoring, you've seen a lot of shots and images and distress surveys from MnRoad. The takeaway of this slide is we're looking at the same thing over and over and watching as distress progresses over time in these sections. So we're also monitoring structural performance at MnRoad with the FWD and then with the dynamic sensors, which I'll show here. So we have strain gauges and pressure plates. Same layout for the Wisconsin sections as well, where we have strain gauges in both the longitudinal and transverse direction with traffic, and then pressure plates on either side. And then the pressure plates are located at the top of the base as well as the top of the subgrade. And then these long vertical pipes going down are our thermocouples, which measure our temperature. So there is kind of an example of what we're seeing. So this is 3 pressure plates all laid on top of each other. So you can see the furthest one inside was that blue line on the bottom. Not a lot of response. The gray is the next one inside, and then the truck is directly over the orange spikes that you see. One of the cool things about the MnRoad section is the collaboration that we did with the PM team with the wicking geotextile. So from a perpetual pavement standpoint, from this project perspective, it really means we got extra environmental monitoring of the conditions. So more in-depth analysis of the structure. So the same structure that I was showing earlier, where we have 8.5 inches of asphalt. The big difference here is now we have a geotextile fabric at the bottom, and then some work in the shoulders going on to tie in the fabrics. So this is what the geotextile fabric looked like. This is the cool part for me is the additional moisture testing. So they put geotextile fabric in half the section and no fabric in the other half of the section where our instrumentation is, or our dynamic instrumentation. And then we have moisture sensors going all the way across the pavement above and below this geotextile fabric. So in the control, we also have the moisture sensors going all the way shoulder to shoulder across the pavement. So moving to the WisDOT section. So these were constructed in fall of 2023. This was, I believe, Sinan, you'll have to help me out. Was this Terrapon's original idea for the project itself, or was it yours? But the whole idea of the perpetual pavement NRRA section came from someone at WisDOT who saw, hey, we're building 12 inches of asphalt here on a bridge approachment. We should use this opportunity to look at the response under 12 inches and update our perpetual pavement or our deep strength design strategies. So kudos to WisDOT for initiating this project. And then working this in. So this was in Osseo. This was a bridge approach. So it was a concrete paving job, and they had about 1,000 feet on either side of this bridge that was going to be a deep strength asphalt. So it really worked out well for us to be able to instrument that one section, one section in each direction. So we were there for a week in October and then back the following week doing the other direction. And it was really nice working with Sinan, Mohammadhossein, Pete Kemp, the whole WisDOT team, and collaborating with them. Here's Pete in this picture here, taking a picture of somebody taking a picture of Sanat and I working. So really good kind of unique collaboration that we were able to do with WisDOT. And we're looking forward to getting the results. So this is some of the, or a cross section of the thermocouple we installed. So this is right before the surface lift of the pavement. We core in through the asphalt and then put this, our temperature tree that's measuring. Really what we're focused on is the top of the asphalt, the middle of the asphalt, and the bottom of the asphalt, so we get a temperature profile for our dynamic responses. Wrapping it up, so perpetual pavements are a tool, especially as we focus on longer lasting or more environmentally friendly mixes. I really want to stress not to lose sight of the overall performance, and what might take us a little more money in design or embodied carbon in the design and construction process can pay off if we're able to make longer performing pavements, longer lasting pavements. Just with the little exercise we did here at MnROAD, we changed 2.5 inches of base and changed the design life from 20 years to 50 years, being a perpetual pavement. Like all of our projects, it really is a full team at MnROAD to get all of this done. And I've already mentioned a lot of the Wisconsin team. I think I owe Pete some cheeseburgers that he bought for us during the construction day. And then great contractors on either side being able to work through this project. All right, any questions? And if there's any interest in joining the TAP or interest in these, please contact me. We'll be working over the next couple weeks with WisDOT, getting the initial draft RFP out to agency members and then posted through MnDOT shortly after that.
Morning, everyone. All right, quick update on the geotech team efforts. Pretty much consider this like a report card. We provided one last year, so I'm just going to build on what we presented last year. Currently, we have 5 active projects are listed here. Some of them are, I usually like to present this in the context of a life cycle asset. So I'm going to just jump into that slide just quick. Let's see if I can do this. There you go. So I like to map the research efforts and the products that are coming out of those research efforts into the life cycle, the life cycle of an asset. So in green, I'm showing here products or research that has been completed since the inception of this alliance. And in orange are the current projects that are currently either active or they're about to start. I want to point out some of the cool tools that I have been found useful so far from the current active projects. So I'm going to start with from the planning aspect. UNH has been working for a couple of years with us on developing this app. It's called PaveSafe, and it's basically it's a kind of nice little tool, very nicely built with fundamental principles of unsaturated soil mechanics and mechanical response of pavements to give you an idea how susceptible your structure is to flooding or to water. So I encourage you guys to use it. There was already a phase 1 on that project. The tool was developed. Phase 2, which is the current one, is working. We are working on improving, validating, and verifying that tool. It's very user-friendly. It's not scary, easy to use, and it will give you a very good idea of how susceptible your pavement is, even current pavement or a future one that you're working on if you're working on the design aspect. So I highly encourage you to go on the website of the NRRA projects and look for the link and look at the reports or download the app if you can and work with it. The other project that I want to talk about that is currently ongoing, that is kind of in the phase of planning, that you can accommodate it in the life cycle of an asset between planning and design, is a very hot topic currently in the geotechnical community that is called the measuring while drilling. I'm going to let Professor Sadeghi, I'll tell a funny story later on. Professor Sadeghi will speak in length in the next talk about that technology, but it's coming with full force. There is a lot of committees at the national level working on this topic, and he'll explain why we're moving towards that technology. In terms of water management, we have currently 2 active projects. And what I mean water management is water management on the foundation of pavements. We are studying the use of wicking geotextiles, an advanced textile that Michael mentioned in the flexible team presentation. He showed that at MnDOT we have currently installed one at the interface between the subgrade and the sub base for this perpetual pavement. So far has shown very good results for us. In addition to providing the typical benefits of geosynthetics, of high strength geosynthetics in terms of strength, confinement, separation, this textile allows you to manage water by removing water quickly out of your system using unsaturated principles. I found that very useful because, again, you gain strength if you don't have a lot of moisture in your system. But I found it more useful is that this wicking geotextile allows you to provide more uniformity in your foundation. And I think uniformity of pavement foundation is quite an underlooked thing or factor. So you may have a lot of moisture, but at least it's uniformly distributed. You have less chances of creating stress concentrations and potential anomalies in your response in your pavement. So I think this fabric is giving us very benefits in terms of creating uniformity right away and throughout the life of your pavement. The other one for water management that we're currently working on is the water repellency at MnDOT 2. It seems very promising. I think some of the preliminary results on this coming from instrumentation are showing that that technology is ready to being upscale. There's been extensive work throughout the years at the lab scale in the lab, but I think MnDOT is showing that it's potentially be upscalable. Funny story is that I think that section, I don't know, it's like 200 feet, it's 300 feet in MnDOT. I can bet money that it's probably the most heavily instrumented pavement section in the world. It has, you name it, you have shape arrays that are usually used for slope stability, horizontally placed. You have wells, you have moisture sensors, you have suction sensors, you have temperature. Incredibly instrumented section for being so short. So yeah, I think that's kind of like the update. We have 5 current projects. I'm sorry, 4 current active projects. And then we have one that is working on the development of the work plan. Curt mentioned that we have this recent cycle of funding for $100K for each team. So we got about 10 ideas submitted. And then the one that won by ranking from the state members, it was a partnership between MnDOT Foundation Office, Joe Neatfield, and Professor Sadeghi from Michigan Tech on piles, on kind of revising the analytical framework and analytical equations that the geotechs used to calculate the capacity of non-displacement piles in sands. I'm really liking how the membership of the team is moving towards other topics that are non-traditional, they're related to geotech assets that are still part of the right-of-way, but are not always just, based on sub-base and foundational layers. We are also starting to branch out into other assets that are part of the realm of geotechnical engineer that are still part of the right-of-way. So I really appreciate that our members are pushing towards that direction. And then other activities and collaboration that I want to highlight. Ben has been bothering us for months about what are the benefits, what are the additional benefits. So I listed some of the unquantified benefits that are not related to really projects, attached to projects, but our members realize that there is a lot of expertise in our team, and our teams are members are very cool and very friendly, and they're always open to help. So I'm listed here some of them. We recently assisted North Dakota DOT as a team in the implementation on LWD for quality assurance. So we are working with them, helping them navigate that implementation process of the LWD. Terry has been using this team for years as to inform and to help him make decisions for changing specs. The most recent one, he wanted to know what other states have in terms of specification for the Los Angeles aberration test. Currently, as you know, we have a lot of issues with environmental aspects in terms of resource availability aggregates. We're having a hard time finding good quality aggregates across metro area. So we are starting to brainstorm the idea of maybe we should start reducing some of the high standards that we used to have for some of the tests to accommodate that issue that we have. So trying to start being open-minded about using less quality aggregates. So that's one of the things that we are using memberships to get information on that. Another one was on assisting interpretation of intelligent compaction on pavement foundations for Illinois tollway. Can be very complicated, as was mentioned during the ICT team meetings presentation. Getting that information could be overwhelming. Interpretation of the data could be very difficult. So the team is trying to help inform practitioners on the use of IC technology for pavement foundation. And another one very important, it seems very silly, but it's on the clarification on the definitions for pavement foundations and what kind of testing we use and for this and what kind of definitions we use for the design. So for example, I didn't want to add the question because there was no time, but Soheil mentioned there was showing the plus of coefficient and the thicknesses and affecting base, subgrades, and mineral, and then he shows subgrade. So my questions to just you guys think about it. What is the thickness of your subgrade? Is your subgrade, you include subgrade that you engineer treated, or how deep you go? So Illinois Tollway came to us, okay, in Illinois we use 2 feet to design and to really probe and to test your subgrade, we need to have a 4% CBR up to 2 feet. So they came to us and asked us, what do you guys do? Mean that, and we start to dig in and explain why the rationale between the parameters, how do we assess, how do we define those? Seems very silly, but for implementation of technology across the states, that's very important. And we speak the same language. What are the definitions for your pavement foundation? So that is also very helpful, that communication between states. So that's kind of the update on the geotech team progress. And then I'm going now, we're gonna give an update on a current project that membership voted for presentation. And that's Professor Sadeghi from Michigan Tech. Funny story. Yeah. He's a racing star, I think. He's taking the lead on this topic that he's going to be talking about, measuring while drilling. He's now leading the users group in the DFI, the Deep Foundation Institute user group for this topic. He's taking the lead now. But during our early stages of our relationship, as he started getting involved with NRRA, I started to get emails from him. And if you get an email from him, you'll notice that his first and last name are very long. So it gave me a lot of anxiety because I want to type the email and I don't want to misspell his name. So it created the first few cycles of communication. It took me every time I sent an email, revise at least 5 minutes, making sure that I wouldn't miss anything. And he was so kind enough that he noticed that I was so anxious about it during meetings that he let me call him Mo. That's a show. So thank you, Mo.
What am I supposed to do? This is the name that I was talking about. That's not a sentence. That's my legal name. So I shortened this for Sadeghi. So
You have a middle name?
it's a long story. This is actually my first name and middle name. But when I applied for my passport, someone put them together. So now that looks like. Thanks for that, actually. All right. Well, good morning. So as Raul's mentioned, the topic of my presentation is measurement while drilling. So I'm going to talk about instrumentation and data management analysis for measurement while drilling NWD technology. Before I get into that, I just want to start by what is measurement while drilling. Okay, so in any geotechnical engineering project pretty much starts with site investigation. We want to know what is underground, right? And we have different methods to investigate the site. Like we have geophysics, we could dig trenches, but vast majority of projects end up with drilling to determine what is in the ground and what is the properties of different layers underground. So we have the drilling. So the whole concept of measurement while drilling is that, as the name implies, that we want to do some measurements while we're drilling into the ground and then use that data for our for different purposes. Okay. So basically, what it entails is that we install several sensors on the drill rig. Okay. How many sensors? What are the sensors? So there's actually, the sky is the limit, or as I like to say, the ground surface is the limit, because we want to put all the sensors on the ground. We don't want to send sensors into the ground. We can, but it gets complicated. So we prefer to put all the sensors above the ground and measure different parameters as we're drilling. So we put the sensors, and obviously we need a data logger to record the data, and then the system of the sensors and data logger is used to record operational and ground response parameters with depths or time or both. Okay, so that's the whole concept of measurement while drilling, or MWD. But what is the goal of measurement while drilling? Well, basically, broadly speaking, we have two major goals that we hope to get from this, all these measurements that we're going to do. The two major ones are to optimize the drilling operation itself. So when you're drilling into the ground, you have a certain rotation speed, you're putting some certain pressure on the drill bit to push it into the ground while it's rotating. So using these data that we collect while we're drilling, we actually hope to be able to optimize that drilling and do the same drilling with the minimum energy used. And it's not just about the energy. If you drill with an optimized method, you could also reduce the wear and tear of your equipment, your augers, your drill bits, and everything. So that's one of the major goals of these MWD projects. And the second one is to improve the subsurface characterization or site investigation. So again, right now while we're drilling, the common practice is, well, as you're drilling into the ground, the soil comes up, so you could use that soil to identify the different layers in the ground. But that's pretty much all you can do with the soil that comes up, because that soil is disturbed. The same soil could have different properties depending on the state that it has in the ground. While you're drilling, you're disturbing it, bringing it on the surface. So pretty much you could use that only for grain size distribution and the type of soil that you have pretty much. But for more detailed information, what we do is we do some in situ tests, or in some locations, we actually put Shelby tubes, for example, if we have fine grained soils, grab samples, bring it to the lab and test them. But those in situ tests or samplings happen on distinct locations. Like for example, on shallower depths, every 2.5 foot. And then when you go deeper, every 5 foot, you collect data in situ testing or sampling. So you have discrete amount of data. But with measurement while drilling, that data is transferred to a continuous recording of all the data. So you don't only have the data points for those specific locations, you have the data throughout. Well, you might ask, okay, CPT does the same thing. So what is the advantage of measurement while drilling over CPT? Well, there's actually a couple. Most CPTs, when you push CPT into the ground, you typically, well, there are some variations that you can, but most of them, you cannot see the soil. So you're just getting some data. Measurement while drilling, you actually can see the soil. It's the regular test drilling that you do. So you see the soil, but you also have the continuous data as well. CPT is not capable of going into hard gravels or rocks, but measurement while drilling, you could actually continuously, when you went through the soil, hit the rock, you could still continue drilling and record data. And these are the couple of major ones, or other advantages, but I'm not going to get into that. So basically, these are the two major goals of doing measurement while drilling. The purpose of this current study that we're working, I'm not focusing on the first one. The focus is the second one, to improve the subsurface characterization. So with that, I'm going to go over the tasks that are defined in this project. The first task was actually to instrument Nebraska DOT's GeoProbe 3230 DT drill rig and do the literature review. We finished that. So I'm just going to go over the instrumentation. So this is the drill rig, Nebraska DOT's drill rig. So we put several sensors. By the way, I mentioned there's no limit. You could put as many sensors as you want. But there are minimums if you want to do site characterization. So, and depends on what type of drilling you're doing. If you're doing augering, hollow stem auger, or continuous slide auger, you need at least 4 parameters measured. The first one is the rotation speed, how fast you're rotating. Penetration rate, that's the second one. The last two are the down pressure, the amount of load that you're putting on your auger or drill bit. And the last one is the torque on the bit. Okay, so those are the 4 minimum for hollow stem auger and continuous slide auger. But if you're doing mud rotary, those 4 are still required, but you need to have 2 additional parameters, which is the mud pressure and mud flow rate. So this drill rig actually is capable of doing both of them and rock coring. So we instrumented this drill rig with the excuse me, with the 6 minimum sensors that we need, or 6 minimum measurements, I should say. So the first one is the drawstring encoder that is placed at the top of the mast of the rig, and this is a close-up picture of that. That actually is the one that measures depth at any moment, and then you could use that to calculate the penetration rate. Then I have a gear tooth stack on location 2, which is used to measure the rotation speed of your drill bit. Then I have on location 3 on the hydraulic lines, I have 4 pressure transducers. 2 of them are used to measure the head feed pressure, and 2 for the torque pressure. So those 4 sensors are used to calculate the down pressure and the torque on the bed. And then I have 1 more pressure transducer here on location 4 that is used to calculate the mud pump pressure, which actually you could actually calculate the mud pressure that is being injected into the hole. And then the last one is another gear tooth stack that is used to measure the pump rotation, which is then used to calculate the injection flow rate. Okay, so those are the 6 measurements that remember the 3 gives me torque and down pressure. So there are 6 measurements that we'll be able to do for Nebraska DOT, the minimum ones for mud rotary. And then this is the data logger that I was talking about. So this is a commercially available data logger by Limb Company. This is the pocket limb version of it. We installed, we connected all those sensors to this data logger. And then now, while we're drilling, we could collect all those 6 parameters. I want to mention this, that like adding this measurement, well, this whole system is not expensive. So for each drill rig right now with installation and sending the drill rig back or to the company to install them and bring it back, it all costs a little less than $40,000. So it's not really, it's not cheap, but it's not that expensive. Okay. So that was the first step of this project. We finished that. Now the second step is mostly Nebraska DOT staff. They're not here actually. Nick Glenny and Alex Silvey, they are doing the drilling and collecting the data. So when they're drilling, this is what you see on the monitor of that pocket limb. This guy, you could see it like as numbers, or you could see it like this. And then when the drilling is done, it actually automatically emailed to me and anyone that I want to. And then also the geotechnical engineers at site, they do the classification, they do in-situ testing or push Shelby tubes, take samples to the lab, do the lab testing. These are all done by Nebraska DOT staff, and then all the data is sent to me. So one of the major issues, I've talked to a lot of DOT staff members. There's one DOT that has been doing this for over 3 years. They have more than 300 bore logs, the data for more than 300 boreholes, and they just basically don't know what to do with it. And then I talked to them, what is the issue? One of the major issues is that it's a huge amount of data, and then it sometimes becomes difficult to actually manage data, organize that data, right? And there are some commercially available website or softwares that you could use, but thanks to NRRA, we were able to buy a server for this project, and then we're able to store all that data on that server, and then, excuse me, we created this GIS-based web map that kind of organizes all the data. I'm just going to show that web map here. This is an interactive GIS-based web map. This is the map we developed for Nebraska. So those red dots that you see on the map, those are the locations of the places that they've already drilled and they have the measurement while drilling data on there. So, and again, as I said, it's interactive, so you could actually zoom in to wherever you want. Like, for example, if I go here, and then some of them are actually like so many boreholes here, and then you could go over there and click on this, and it gives you an overview of the project. So the project name, the latitude, longitude, what machine was used, what type of drill bit, was it a hollow stem auger, was it a mud rotary, bunch of other information. But also you could actually store files in this location. So like, for example, if I click on this here, it actually gives me the measurement while drilling data that was recorded there. This is the PDF. If I click on the other one, it actually downloads the Excel file of the same data. Okay, and then this is just an example. We decided to put two data or one PDF and one Excel file on there. We could do as many as we want. That there's no limit for that. So this was the second pass. So, and I think it's a very neat way of organizing all this huge amount of data. So now everyone can actually go there and look at whatever data they want and collect that. And then hopefully, eventually, I don't know if it's in the purview of this project or not, but later on, we're going to add the correlations onto this web page as well. So you could actually get your measurement while drilling data, put it in a like interactive software on the web, and then get whatever parameters that you want. That is my hope for the future. So that was the task. Did I mess up something?
It's the computer. Switches to presenter mode, and then I can't see it on mine.
Oh,
no, thanks. Yeah.
Again, so this task is almost over. We just have one little hurdle that we have to figure out, because some of this data, maybe the owner, the DOT, don't want everyone to have access. So we're trying to actually, right now, if I publish this, everyone can download everything. So we're working on limiting access. So who can, like, for example, if it's Nebraska DOT wants only Nebraska DOT people to be able to download it, or give access to some other people. So we're working on that. But other than that, the map is ready. And then for you to add your data into this web page, all you need to do is store your data on a certain folder that we tell you, and then populate at least four cells in an Excel file. And then it automatically, every Friday at midnight, it actually updates itself. We could do it more frequently as well. If we wanted to do, we could do it every day. Okay. So task 4 is one of the tasks that we're currently working on. It's basically the pre-process the data. All this data, again, it's a huge amount of data. It's raw data, so we have to do some pre-processing, some cleaning of the data, as you can see in this figure. Some of, like when you stop to add the next flight of auger, the drill rig, the measurement stops. So sometimes we have very small penetration rates there, like 0. So we have to clean those up. So that's what we were doing. And then also, so the measurement while drilling data comes in, then they have a separate PDF with all the in situ data, soil types, bore logs, and like lab tests if they pushed Shelby tubes, compression strengths. So we have to combine all of them in one Excel file like this. So this is another a huge part of this project, that we have to combine all of them in one Excel file. Now you could use this Excel file to actually improve your class, like site investigation. So that's what task 4. We're heavily working on this. We're pretty much up to date, and we were able to automate as much of it as we could, but still there is a little bit of like things that you need to do by hand. So that's the time-consuming part of this whole thing. And then another pre-processing thing that we have. So some of this project, we also have CPT. We wanted to see the correlation between CPT and MWD. So combining them in one Excel file is not that easy because yes, both of them are recording data with depths, with time, but sometimes those intervals that they're collecting the data don't match. So you have to do a little bit of work to actually combine them, but this is fully automated because measurable drilling comes in an Excel file, CPT comes in an Excel file too. So we wrote a code and then automatically combines them like this. So now you have up to the first column that, or the second column that is yellow, all this is measurable drilling. And after that, there are all the corresponding data for CPT. And the depths are not exactly matched, but there are difference by less than 0.02 inches. And that's optimal. I could actually make that even less than that, but that's the number that we picked. We thought that would actually be enough. So that's another part of the pre-processing that we had to do, which is fully automated. Now, the main focus, the part that I really like about this project is to actually sitting down and analyzing this, trying to find correlations between this. So the way we use these measurement while drilling, the most common one is they combine all these raw data to some compound parameters. There we have like 11 of them, and then try to correlate them with different properties or soil types. So one of them is, for example, a specific energy. All those variables that you see in that equation at the bottom corner are raw measurement while drilling data. You combine them to one parameter, and then you could plot that parameter with depths, and then you could actually look at to see how that correlates to different soil types, SPT numbers, and things of that nature. But as you can see, this is going to be very difficult to do by hand because then you have to go back to your bore log and manually put all of the match them. It's a very time-consuming thing. So we actually fully automated that part. And then another thing is the scale is a lot different. Like look at the first 25 feet of this data. All that data is actually seems like pretty constant, right? But it's because when you go deeper, you actually go into shale. It's called CLCH, but it's actually shale. So it's kind of a rock or intermediate material. So actually all the data, actually the range is a lot higher. So you cannot see those variables. And if you're trying to do this with Excel, it's going to be very painful. So we automated this with a Python code. So now it could actually calculate the specific energy or any other one of those 10 compound parameters and plot them versus the soil type. And then automatically you could actually maximize that one section that is out of the range that you're looking at the whole data. We also did the same thing for USCS classification instead of the full material description. So the goal was, and I'm running out of time, I'm going to go through these a lot as fast as I can. So the goal was to find two parameters that I could use to develop a plot like this. This is a plot that we use for CPT to classify soils, right? My goal was to find two data or two parameters combined or individual to actually develop a chart like this. We found out that these two parameters work best, but still, even the best case scenario, this is what I can get. As you can see, there's a lot of overlap between the data. And even if and this is the full data, then if I even reduce the types to just clay, silts, gravels, and sand, still a lot of overlap. So there's no way for me to separate these two by just using two parameters to be able to develop a chart like that. So, and I didn't even stop there. I tried to use some machine learning, but with two parameters to see if I could find some combination of two parameters to classify these. I was not able. As you can see, the accuracy is 26%. So, again, even if I reduce so this is with all the actual USCS classification, but if I reduce them to just clay, silts, sands, and gravels, the accuracy goes up to 74%, but it's not an actual accuracy because like more than 80% of my data is clay. Okay, so even if you guess something as clay, you're going to have a high accuracy. So that's not going to work. That's not an act. That's a pseudo accuracy. So, but the issue with this is that when you're using individual parameters or compound parameters, there are things, certain things that there are important, but you cannot take them into account. Like, for example, the effect of groundwater table. Some of these measurements are above groundwater table, some are below. They're completely different animals. So the effect of depth, the confinement pressure, these are not considered in these calculations. Drilling procedure itself has a lot of effect on this data. So you cannot take them into account. Additionally, like if you're doing a hollow stem auger, I'm sorry, mud rotary, all these compound parameters, none of them actually take into account the mud pressure and the flow rate, which are important in your calculation. So what do we do? So I decided to look at the data-driven machine learning approaches. And it actually, we tested a lot of different methods, and support vector machines actually worked really well. The accuracy is 92%, but this one is more reliable. Just look at this data. I trained my data and then kept some of the data out, then used the trained model to predict the label. And then, so these are, for example, the predicted label, but the actual label was not. So one case that happened. So that's an error. The ones on the diagonal, those are the correct ones. If you look at the data, I tested almost 4,200 data points, and I only got 300 of them incorrectly. So it's promising. The next step was to develop correlation with SPT. I'm not going to go over all the details. There are certain things that I had to do, and then I looked at all 10, or actually 5 of the compound parameters, namely these ones. And again, regular correlations do not seem to work. The best I could get, if I separate the samples to fines and coarse, actually Sommer index actually has a decent coefficient of determination. But if I do not separate the soil types manually, the coefficient is not good. Again, going back to machine learning, actually I can see that instead of using just 2 parameters, I could use 9 input parameters. And then with those 9 input parameters, I could get the accuracy up to, coefficient of determination to 97%. We also developed correlation between measurement while drilling with CPT. Again, trying to use traditional methods to find correlations. There are some trends that are similar between CPT and SPT. I'm looking at the combination of all different parameters from measurement while drilling and CPT. There are some similar trends, but there's no correlation. I could not find any correlation between the data. Again, going back to machine learning, using 9 parameters instead of 2, I was able to get coefficient of determination of 0.9 between measurement while drilling and the tip resistance, side friction, and even the pore pressure. So there's really good relation. You could really get good correlation, between measurement while drilling and the parameters that are important in design of foundations. Okay. I just wanted to thank my research team, my students Michael and Yasaman. They helped a lot. Special thanks for NRRA and Minnesota DOT for supporting this project. Nebraska DOT for letting us instrument their drill rig, doing all the heavy lifting, doing the field work, lab testing, and also thank to my technical advisory panel. That concludes my presentation. Are there any questions? Exactly, that's absolutely true.
Or the same drill or different drill rig. What is your comment on?
Okay, so that's actually a really good comment. We actually have a presentation last week in our DFI user group from Montana DOT, and they were actually talking about, they actually looked at the data, everything the same, just, well, not everything the same, like the soil profile was similar, but everything else was the same, with two different drillers with different preferences, and the data was actually very different, the correlations. The correlations, though, that were developed based on compound parameters, right? But when you're using machine learning, there are still different correlations, but the correlations are better, okay? So now one of the things that we are doing, we're trying to develop, AASHTO is actually working on this, developing the standard to minimize the changes that is caused by different drillers, right? If that comes into place, and then instead of using compound parameters machine learning, the hope at least is, I'm optimistic that we could get over that hurdle, but we have to look at the data to say that for sure. But that's a really good point. Yeah, that is one of the concerns right now. And it's not just the driller, even if you switch the drill rig as well, that the same thing happens, yes. And another thing along those lines is like how much, like if you use a new like auger with one that is like 80% ward, that also affect all this data. So, but all of those you could actually include as an input parameter in our machine data-driven data. Sure. Trying to. Thanks.
So we're on break till 10 o'clock. If Tara, Heidi, Dan, and Emil could come up and get your presentations on the computer, that'd be great.
All right, we're going to get started with this next session here. My name is Tom Burnham. I have the privilege of being the chair of the NRRA Rigid team. I don't quite have a sophisticated presentation as some of the other chairs, but nevertheless, we do operate in a very similar fashion of a lot of collaboration, putting out surveys of when we have to choose how to spend a pot of money. We'll put out a survey and get a lot of cooperative understanding of what everyone's interested in. And we've come to some good conclusions out of that process. So today I'm just going to start with a very brief presentation on some of the rigid team activities that we've been involved with right now on active projects. So again, we heard a lot yesterday about the MnROAD test sections. They've been keeping us very busy with 24 new sections. So right now, keeping track of what's out there, we actually have 27 active pavement test sections on the main line and another 24 on the low volume road. So we have a lot of sections that are being monitored there. A mixture of different types of pavement, predominantly jointed plain concrete. We do have a couple of thin fiber reinforced concrete pavements out there. And then we have one ultra thin fiber reinforced concrete overlay on concrete. We did lose a number of sections on the main line. A lot of our thin concrete overlay sections, we lost those again last year to the effort for the new initiatives related to low carbon and also just beefing it up in preparation of that GAP project. We do have test sections from all three phases. We still have some originals from 1993, and that would be 36 and 37. And if you go on today's tour, you can go out there and see those still holding up very well. A lot of talk again. Our major initiative is that lower carbon content concrete pavements. And out of that, we have 4 different active research projects. 3 of those were initiated in 2022, and we heard updates of those yesterday. And then for the sections that we built last year, we just initiated a new project this year, the Innovative, Sustainable, and Durable Materials, which just covers those additional 8 materials that we're looking at. Last fall, we also had the opportunity to place some Dolitic calcium sulfoaluminate cement. So in other words, a rapid set mixture on the low volume road as a kind of a trial and getting some understanding of how that operates in a cold climate here. And we really tested it. The placement temperature was 35 degrees when they put it down there. So I don't know if that was their coldest placement, but it really pushed the limits. And our thermocouples show that within 2 weeks it had frozen already. So it'd be very interesting to see how this performs in the climate at MnDOT here. As far as active projects, we have a number of them. I'm actually involved in the first two here is PI and co-PI. The first one is the early loading to increase joint deployment of thin concrete overlays. So again, the idea of sometimes we'll solve 6x6 panels, they don't all deploy, and we're wondering, is there techniques that could be applied to maybe encourage those to deploy? Because we're really kind of relying on that for the design. Then another one is, again, we heard about yesterday, utilizing the performance engineer mixture repairs and the diamond grinding of the thin concrete overlays. So those two projects are kind of ongoing. Those are internal MnDOT projects. Then external, related to NRRA, we have a new one, automated 3D GPR analysis for concrete pavement evaluation. So how can you take these 3D GPR images, and specifically when you're on concrete pavement, how can you speed up that analysis so that it's not so much manual labor? So that project's active. We're going to hear shortly here from Tara about reducing embodied carbon with the Microspheres project. And then we have the concrete construction report, which again reports on the early findings from those 8 sections that were built last year. And that's being done by Larry Sutter. Should have those results, I think, Maria, if she's still in the room, should be having those results coming out pretty soon. We are also internally working on the construction report that reports on all the activities that we are involved with as we build these test sections. If you're ever interested, again, you can go to the project or the team website here, and you can always have a list of all the completed and active projects that are going on in NRRA. So with that, I'm going to introduce here Tara Cavalline, who is with the University of North Carolina at Charlotte. We welcome her to talk about and give us an update on again, the Microspheres project. So welcome, Tara. You ready to go? Thanks.
Thank you very much for having me. What I'm going to present today is kind of the joint work of us at UNC-Charlotte and the good folks at the CP Tech Center at Iowa State. My grad student, Rohan, has been doing the heavy lifting, or more accurately, lots of sieving. And Peter Taylor and Dan King are with us. Thank you very much for having us. I'm going to give a little bit of an overview of microspheres. They're not the generation of microspheres that you may remember if you did concrete canoe back in the 90s like I did. This is kind of a newer technology. I'll talk a little about how it's different. Talk about what we came up with for the MnRoad installation, laboratory data that we've got from both that project as well as the field placement and data, and then some ongoing work that we have to further explore this technology. The older version of microspheres, and I only joke, I actually worked with microspheres back in the mid-90s. We had them in our concrete canoe. They were nice little floaty things that you could put in there and lower the unit weight of your concrete. We weren't actually using them for freeze-thaw durability. We're essentially using them to lighten up our mix. They were brought to market a while back, and folks struggled with them. There's a mixed performance history, primarily because they were agglomerating within the mix and kind of tending to sort of static charge together and not dispersing. This particular product that we've been working with is a little bit different. It's gas filled, and the process is a dry expanded process. They've actually blended it in a mineral calcium carbonate. So essentially, instead of a slurry like they used to come in, although you can still get them in the dry bags in the older form, this new version is interspersed in a calcium carbonate mineral powder, and that helps disperse them. Essentially, you're reducing that static charge. You mix it in the dry powder form, and then essentially you get this good dispersion of this material. Research is showing that if you put about 1% by volume, so if you think about that, we're currently air and training anywhere between 5 and 8% to get our freeze-thaw durability. With these microspheres being the smaller size that they are allowing space for freeze-thaw stresses to be accommodated at about 1% by volume in that mix. So I'm going to talk a little bit about the implications of that in the next couple slides. But essentially, we've all known that, especially in places like this, even in North Carolina, we cross 32 degrees multiple times a day. Sometimes we do experience freeze-thaw distresses down south as well. we need our entrained air to get that freeze thaw durability. However, we know it's one of the most frustrating things that we deal with. My particular grad students for our DOT projects, I hold them to an air content between 5 and 6% on anything we keep, because I don't want to have to attribute some effect of the air to some other property I'm interested in. So we waste a lot of concrete both in the laboratory as well as out in the field if we can't control that air content and bring it within the range that we're looking for either acceptance or even just to design our mixes. Essentially, we all know that some fly ashes, particularly those with high carbon, are giving us challenges. We have a lot of ashes that are sort of marginal or problematic, and microspheres might be a tool in the toolbox. We're not talking about this product revolutionizing the entire industry because there is a cost associated with it. But that being said, if you do have a good supply of a marginal ash, and you can get your freeze thaw durability by adding these microspheres instead of dealing with the issues with an inconsistent entrained air void system with conventional air entrainers, could be a solution. And then secondly, from a sustainability standpoint and also an economic standpoint, if you're going from anywhere from 5 to 8% air, as I tell my students, the compressive strength of air is 0, right? But now you have 1% air by volume of these microspheres. You've now gained 5% by volume back to 7%, essentially that you can put something else in that mix that holds load, reduces permeability, does the job of concrete, right? So you get some space back in that matrix. And so that sort of is part of what I'm going to talk about today too. It's an ability to reduce clinker content, an ability to reduce permeability, an ability to get the same strength at a lower cementitious materials content. So it does offer that advantage as well. So essentially one of the questions is, how do these work? And essentially this little diagram kind of shows you what's going on. The coefficient of thermal expansion of these polymeric microspheres is actually much greater than the paste matrix. And so as you have changes in temperature, the decrease in size of those microspheres leaves an annulus void. And so as the temperature drops, you know, everything's contracting, but the microspheres are contracting more than your paste matrix, leaving a space. And since they are so tiny, and now this new technology is allowing them to be dispersed more effectively, they're giving you the space to resist freeze thaw distresses. So the question is kind of, can you get the same freeze thaw resistance with a lot of tiny little bubbles like that dark blue one versus a lot of much larger bubbles through a conventional air entrain system? So what we've got here, and this is actually the material we're using. We used to have sort of this agglomeration. Now what you see when they're coming in with the mineral powder, they're a lot more dispersed, they repel. The product comes in a fairly easy to use format right now. Essentially you put 5 pounds of the material in per every cubic yard. 5 pounds of something that weighs about nothing is kind of like throwing your bedroom pillow into the back of the truck. These bags are super light, and you put them in the top like that. Right now, the technology, there's actually some publications in the ACI journals how to compute the required space, but for a lot of mixtures that's sort of the proportions we're using right now, this magic number of 5 pounds per yard seems to be the number. The bag dissolves, and essentially they're working on a technology to either dose the bags at the batch plant or essentially potentially have it pre-mixed with cement if they're looking for a long-term supply solution. That current cost is about $8 to $9 per yard. They're also working on getting that down as well. How do you actually see these and what kind of QC can you run? The interesting thing, you can't use the pressure meter because they'll actually pressurize and then you're not going to read them, but you can see them in the volumetric air meter and you can literally see them in the column there. So you run your volumetric rollometer. My student Rohan people have joked he's the fastest rollometer user in the country right now because of the number of times he's been doing this. You just can't add the alcohol to bring the foam down because the alcohol will dissolve the microspheres. But the foam doesn't matter because you're actually literally looking for 1% in your neck of your rollometer to show you the microspheres there. So that's kind of how they work. What do they look like? And there were some emails flying around a little bit ago about how do we see these under a microscope. If you look at about 200x, you can see them. And so those of you that might be familiar with looking at concrete under a microscope, this is about 1 millimeter. That's your conventional entrained air void from an admixture. These are your microspheres. They are super small. And if you think about how they're accommodating that freeze thaw pressure, being so, at only 1% by volume, they're much more well dispersed. They're closer together. And essentially you've got these tiny little void spaces that can actually accommodate it. You can do an air void count with them. They're tricky to see, but you can see them at 200x. So that's sort of where they are. And we've done some work at UNC-Charlotte prior to MnROAD. And that's sort of the proof of concept that we did. I was actually approached by a ready mix supplier in the Charlotte market that was kind of tired of having some of his trucks rejected. And we didn't have a huge budget. I'm not going to say what the budget is because my vice chancellor of research will look at me and roll his eyes that I actually did work for that money. But I was really enticed with this idea of this product. And so we actually ran 3 rounds of 6 mixtures apiece, with the ready mix supplier producing the concrete and us just running freeze thaw testing, ASTM C666, procedure B. And we were running it for anywhere from 600 to 900 cycles. So our first round, we ran 900 cycles, and we did not get below a dynamic modulus reduction percentage of about 70 to 80%. I couldn't believe it. The students wanted to strangle me. So we ran 2 more rounds at 600 cycles. The lowest we got, that's actually a sidewalk mix that's appropriate for Charlotte city streets. And even after 600 cycles, that would pass in most states. So we've got some very excellent performance out of these. If you want to see the proof, anybody that loves to see beams after being tested, these have survived 900 cycles in our freeze thaw chamber with 0 entrained air in them, just 1% by volume microspheres. So we were pretty excited about it. We talked to the folks at the tech center and we gave a few presentations. We actually got one of our studies published in Concrete International, which is the ACI publication. So we've got some folks interested in it. But our goal at MnROAD, and again, I know Bora yesterday said, thank you for investing in this. I'm super excited to see this, kind of, where's the better place to see freeze thaw damage? Minnesota. Let's take it there. We wanted to see what we could do with these, observe the performance, see what kind of reductions in cement content we can get, and then sort of quantify the sustainability benefits, right? We realize that essentially now we're kind of opening the market to some ashes that might be available that are marginal or tricky to use or currently not being used with this product, but also how can we justify their use if we can actually lower that cementitious materials content? And so we've got 2 mixtures that we put in this round of 2024 installations. We based one of them on the MnROAD control mixture. So we essentially took your Minnesota concrete paving mixture and we took out the 6-7% air, put in 1% by volume microspheres. I'll talk a little bit about what we did with that extra space in a minute. We also have one mixture based on Peter's 2022 optimized aggregate packed in their system that he came up with that he talked about yesterday, where we reduce the binder. So you have a reduced binder content mixture as well. And so we did end up, we talked to the producer and we said, all right, what do you want us to put back in here for that 5% air that you don't need anymore? And he said sand, right? And then we tried it and they were harsh as all get out. You're not going to be able to just put sand in there for that extra 5% volume. And I have worked with Larry Sutter a lot. And my biggest fear in this whole thing was having Larry Sutter on the top of the truck saying bad words about a mixture I designed. That was not where we were going. I told the grad student, I said, we will mix until we run out of time. We will have this right. We will have it workable. We will have it pavable. I had heard all these stories about different situations with mixtures not being field ready. We wanted ours field ready. And so what we did was we decided we were going to actually add some sand, but we're going to make a lot of that up with fly ash. So we increased our fly ash percent from 30% to 40% in these mixtures to help us with that. We did not mess with the combined aggregate ratios. So essentially our mixtures are comparable to these controls in the sense that the same volume is taken up by those aggregates. We didn't want to mess with the paste and void ratios. We did add the fly ash in there. Here's our aggregate gradations. We did use a 3 aggregate system. And those of you that are familiar with the tarantula curve, what we have here is essentially our MnROAD mixture with the microspheres actually essentially matched the MnROAD control, and a reduced binder mixture was pretty close, right? So we have an aggregate system that's allowing our microspheres mixtures to be compared to the mixtures out in the field. What we ended up with though, because we did have to come back with some cementitious materials in that 5% space that we needed to fill where the air was not. You can see that the MnDOT control there has 0% microspheres. We have 5 pounds per cubic yard, 5 pounds per cubic yard on the other two. We did estimate that we'd have some entrapped air in there, so 4 to 7 was what we used in our math. We did use 40% fly ash, but you can see we're still a little bit higher on the binder than we wanted to be. But we also have room to continue to drop this in our lab, and I'll talk about that a little bit. And we definitely know that we can, because when we look at the paste volume down at the bottom, we all know that we can get somewhere below 25% in most of our paving mixes and still be able to get it through the machine. So we did, this is now out at MnRoad. The MnDOT design with the microspheres was actually placed first. The weather was sunny and clear, everything went well. One of the things that we found out was adequate workability that looked to be our VCALI measurements that indicated good pavability were one thing in the lab. But when you started adding the mechanical energy of having a truck mixer rather than the energy of the drum mixer in the lab, we had a more workable mix. I still argue that I would rather it be too workable at MnRoad than not workable enough. You can see them holding an edge board up there to keep their edge while they were paving. But I was really proud to say that our mix was not the problem that day. So that being said, the second one was placed with the reduced binder. That one, next day, same thing. We had room to hold back water, which is actually a really great thing. And so they have that in place right now as well. The MnDOT control went in the third day, same thing. Here's a little bit of the data. You can kind of tell, particularly with our slump measurements, that we had some room where we could have held back water. And then if we could hold back water, we could also reduce some more cement content. We have room to improve the mixtures that were there, but there's not a single drop of air and training admixture in these. And we did get good results. And if you're familiar with VCALI, we've got some room to improve there as well. We're going to be working on that in the lab. How did they do? Well, similar to what I had just said. Essentially, our MnRoad control there is in the blue, and our compressive strength showed us we had plenty of good strength. I know Maria does not look at strength. That is a external measurement to her, which is an excellent way to look at things, but we also do track it as well. Here's our field data on our flexural strength, also beating the MnRoad mix, but indicating we have room to pull cementitious materials out, drop that water cement ratio, tighten up that BIC some more, and really see how low we can go. Our resistivity, same thing, higher than the control. Lots of good durability predicted from that measurement. How did they do in freeze thaw testing? And here's where I was like, oh, thank goodness, right? You always think, you run a tight ship in your lab. I trust my students. I trust the work we do. But honestly, after running 3 sets of these, they were performing so well. I was like, this is just crazy. But AET ran the tests, and their freeze thaw at 300 cycles was right where we fell. They had, for the MnDOT control, 95% dynamic modulus, and our 2 microsphere mixes, 94 and 96. So essentially, with no air and training admixture, they were getting the same freeze thaw prediction that we got. So thank goodness. Always nice to know that your lab results are not a fluke. So that was nice to see. They did get out there and do a preliminary 1-year walkover just the other week. There's the mixture with the microspheres looking great. Here's the one with the reduced binder content. Looks a little different because they did do some diamond grinding. My understanding was that was not necessarily due to any of the mixture characteristics, but more for the whole surface profile of the section as it sits. But there was no visible signs of distress after this first winter. Things are going well. And so what are we doing moving forward? Clearly, we have room to see how low we can go. And so our steps at UNC-Charlotte this summer, we are now essentially dropping our cementitious materials content. We are trying to get a hold of some fly ash with a high carbon content to add that to our mixture testing. And then essentially our new testing, we're adding some of the durability tests that haven't been done before. Scaling, salt ponding, water absorption, bulk diffusion, and some shrinkage. So this is what the grad student will be working on this summer, kind of under another scope of work that should complement this and give us some more confidence in how this performs and a better understanding. So many thanks to everybody that's allowed us to get to this point, especially the students that dealt with 600 and 900 cycles of freeze thaw testing over anywhere from 6 to 9 months. Our project panel has been super helpful, and this has been a great experience. We're looking forward to seeing how it goes. And I really look forward to seeing, once we figure out exactly how much cementitious material we can pull out of this and do some of the LCA and some other sustainability analyses. It's great. We could open up an entire realm of fly ash that's been undesirable for a while with this tool in the toolbox. But let's really see what else we can do by dropping our cementitious materials and capture that savings as well. See where this could potentially lead. So thank you so much. That's all I've got. That's a good question. We've tasked the grad student with that, right? Like, okay, so we suspect that the annulus void forms and closes, eventually do you wear out the microsphere, right? Do you fatigue it? What actually is the mechanism? Can you actually see the physical, how does this actually work from a micro scale? We're working on that. So hopefully the extended sort of PhD contribution work that Rohan will be getting will be helping to look at this on a smaller scale and really taking a look at, can you wear them out? The other piece of this, this is a microplastic, right? And I'm not up here to be a product salesman by far. I lived in the repair world for long enough to know that, you talk about the technology, not the product, but this is a plastic product. And if you think about it, regular abrasion, you have this potential source of that too. So that's something to think about, that we've also put on our radar, that, a true sustainability analysis would also need to think about that as well. So.
Hello, everyone. My name is Tyler Hunt. I'm the chair of the PM team here at the National Road Research Alliance, and I'm just going to give a quick update. A lot of my co-chairs have already done great updates, so mine's going to be pretty quick. Some of the stuff's already gone over, so I'll breeze through it a bit, and we'll move on to the more present presentations. We have our 3 ongoing 2023 funded projects. I just wanted to give a brief touch on where they're at. You heard from Dr. Yu yesterday, his presentation on the hot rubber seal coating. We successfully completed that M25 job in Michigan, which was a total success as far as I'm concerned. We had some scheduling conflicts with folks in Minnesota to get over there and kind of check out the treatment, but I'm working with Dr. Yu. I'm hoping to get another one done. So if anyone from any of the states wants to come out and see a hot rubber seal coat be placed, let me know. But Dr. Yu's outfit is working on task 3, and I think we're well on our way. So hopefully that's correct. I see you nodding. So that project's going well. You're going to hear from Dan in a minute, so I won't steal any of his thunder. But the materials-based methods to improve rumble strip durability study has gone very, very smooth. We actually had 3 test locations in Wisconsin that Dan had already set up prior to the project even kicking off. So things have just been really rolling. He recently completed task 4, which was some interesting lab evaluation and testing. Ran into a few hiccups there. I think Dan maybe will touch on that on some of the oven aging, but we got through it. And I think task 5, as far as I'm aware, is coming out end of April. So that project's actually gonna be wrapping somewhat soon. So kudos to that team. Unfortunately, Adriana couldn't be here today, but the recycled materials research is continuing. Mule's the technical liaison on that one. We've gone through task 1 and 2. So we've developed the experimental plan. There was a bit of a hiccup acquiring laboratory equipment. I see Emil nodding, so that's hopefully correct. That we've had a bit of a delay on that job, just because I think, as I'm finding, as the more I get into this industry and the years ago, it's hard to find equipment for such a specialized industry, especially preventive maintenance. So when there's delays, it's not really surprising, but we're getting set up for that. And I think we're extended out to February 2026 for that one. So more to come. So those are our 3 2023 funded projects. A few other of the chairs have talked about the additional funding. The PM team met back in March, and Lauren was kind enough to provide a sort of poll for me. We came up with 8 research ideas for that, and full disclosure that the Utah High Mod actually rose to the top but just below it, one volt below it was the spray-on rejuvenator test section extension. So as the team chair, I kind of made the call that I wanted to go with that co-funded extension with the Flex team. I think there's a lot of value there. It's not that there isn't value with the Utah High Mod. I just think there's other research opportunities for that treatment. Unfortunately, I should have put the list in here, but we had great research ideas. We had a lot of interesting research ideas on plow skid wear, and I'm gonna forget, but there was just a cool idea. So I appreciate the team, agency members and associate members. Thanks for providing all those neat ideas. I'm maintaining that list of research ideas, so we'll continue that in the future. But for now, we're gonna extend the spray-on rejuvenator test section to year 3 and beyond. So I think that's going to provide a lot of useful data. I just want to put a plug for our team meetings. We do meet monthly, and then we do quarterly joint team meetings. I'm sure everyone in the room is aware. If there's any topics that you want to discuss in the meetings that are not related to any of our ongoing research, but you think it's just a cool idea, as Michael has said, we're a bunch of pavement nerds. We get together. I think it's a great opportunity to just kick ideas around. I think it can be related to some of the other organizations, NCPP, or some of the stuff NCAT's doing specifically. Anything you want to talk about, please bring that. We've had pretty decent attendance at the meetings. And if there's anything I can do to make it better, let me know, is basically what I'm saying. So that's my short presentation. I do want to say a few thank yous to everyone, Ben, Lauren, Lisa, and Joel from MnRoads and MnDOT. Curt and I have talked about this, being outside of the sphere of the halo of Minnesota DOT and MnRoads. You're kind of an outsider, not an outsider, but we don't feel that way, right, Curt? So I appreciate all the help in moving the team forward and all these, just the assistance. I felt like I was drinking through a fire hose when I started, and I don't feel that way anymore. So things are going great. I do want to say thanks to Curt and Michael from Flexible Team. They're extremely helpful to me in getting all the extension set up, and they've taken the reins on so much stuff, which has helped me tremendously. Joseph Podolsky and Emil, my PIs, and then of course all my researchers and associate members. So I just want to say thanks to everyone. And with that, I'm going to turn it over to Heidi.
Thank you, guys. I just wanted to give you guys a quick update on this research project that actually it started back in 2017 and concluded spring of 21, I think. That's when the final report actually came out. But when I heard that the old westbound was going to be reconstructed for the I-94 gap project, I wanted to just get out there and take one more look at these patches before they were torn out. So this is the effective, long-lasting, partial depth joint repairs for challenging conditions research project. I think most of you should be familiar with it, and I'm sure if you don't remember this, will remind you. So just a little bit of a background on the project. So the purpose of this project was to review alternative patch materials for partial depth repairs, and then to monitor whether those materials last longer than a typical asphalt patch or concrete pavements. So it's just kind of showing what happens to asphalt patches after a couple of years there. So the process, so that MnRoad and MnDOT manually created partial depth distresses along that old I-94 westbound section at MnRoad. So there was 15 different test cells, and each test cell had 11 different distresses. So this kind of maps out the different types of distresses. So kind of the different joints. The purple squares were actually the mid lane, and then the yellow ones, the corner panel ones. So kind of looking at patches on different areas of a panel. And then there was 17 different products that were used to patch these distresses. So one of those was just your typical HMA patch, and then there was 16 different proprietary products that were used. So that's what's listed there, and then just like what type of material it is. So that very first one up there, Aqua Patch, was the only other like asphalt type of a material. The rest of them were either a polymeric or cementitious material. So the patches were installed in 2017, fall of 2017. Then we went back each year after that from 2018 through 2020 and did an annual condition review of those patches just to see how they're performing. And to evaluate the condition of those patches, we came up with this rating scale. So a 4 would be considered that the patch is still in excellent condition. There's no distresses other than maybe shrinkage cracks. A 3 is good condition, meaning that there are some distresses in the patch, but 100% of the patch is still in place. 2 means that some of that patch is coming out or had to be replaced. And then a rating of 1 means that more than 50% of the patch had been replaced or has, is gone. And then a 0 means that the patch has failed. And we originally defined that as just saying that the original patch no longer exists. After going out there in fall of 24, I kind of had to redefine that failed. So I included or that the patch has been 100% covered by another product, because at that point, I don't know if the patch is still in there or not. It's been covered up. So I couldn't tell you if the original material is still there or not. So these were some of the assumptions that we had to make. So based on that rating scale, the 0 to 4 rating scale, we assumed a terminal service rating of 1.5. So once a patch is at a rating of 1.5, it's probably going to get replaced. And then we wanted to define what is a long-lasting patch. So a typical HMA patch is expected to last about 2 years. So we wanted a long-lasting patch to last at least 3 years. And so based on those assumptions and the conditions that we reviewed, this is kind of the results of the estimated service life. So what we were able to do is take the condition from each year, from the 18, 19, and 20, and plot a deterioration curve of the condition of each material, and kind of predict an estimated service life of that material based on those condition points. So yeah, there was 14 out of the 17 products that had a service life of longer than 3 years, and 9 of those were actually projected to last longer than 5. So that was great to see. And so some of the conclusions from that final report, so that's from spring of 21, there was quite a few either cementitious or polymeric type products out there that are considered long lasting for partial depth patches. The performance of the patch, this probably seems pretty obvious, wheel path versus non-wheel path. So the patches that were in a non-wheel path location, so the mid lane, like in that picture there, or the corner panel ones, they had a better performance than other patch areas. And then opposite, wheel path, WP was the wheel path patch location. That one was below the average, so kind of makes sense. Another thing that wasn't necessarily intentional as part of this research project, but some of the distressed areas were not sandblasted, basically just due to lack of time. We wanted to get the patches in. There just wasn't enough time to do sandblasting for all of the distressed areas. So it ended up that for a few of the test sections, only the drive lane was sandblasted. And then the passing lane, it was just with a leaf blower, just like air blasted, cleaning out the debris. But it worked out, so we were able to kind of use that as part of the research as well then. So comparing how the condition, how it turned out for the sandblasted versus the not sandblasted. So that's kind of just showing how those conditions compare. So sandblasting, it did typically have a better performance. Okay, so fall 2024 update. So like I said, I went back out there last fall with some of the MnRRA staff and just took one last look at the patches before they were ripped up. So at that point, the patches would be almost exactly 7 years old. I think we went out there at the very end of October. So So the middle column is the 2024 condition, again, using that same 0 to 4 rating scale. And then that last column is just showing again what our predicted or our estimated service life was from the final report. So you can see there's still quite a few products that are doing really well. 11 of the products are still above that 1.5, terminal service rating. So, and just looking at individual patches, so not necessarily broken up by product, but there was 95 of the 165 patches that are still above that terminal service rating. And then just kind of reviewing that data, the conditions still confirm those conclusions from the final report. So the sandblasting versus not sandblasting, and then the location of the patches, the mid lane, those ones were performing better than the wheel path, obviously. And so, yeah, just wanted to add a few photos. So these are 2024 photos of those patches. These are kind of those top performers, some of the top performers. There's, with 165 patches, I have a lot of photos. So with that, I am planning to have an addendum to that final report and then uploading all of those 2024 photos. Those will be on the project website soon. Yeah, so that was it. Any questions?
Just so you know, I went home last month. I took more photos. So
oh yeah. Oh man.
Another winter.
Yep. There you go. So yeah, lots of photos. Yeah, he's got a flash drive with the 24 ones. So cool. Yeah. Yeah, I think it was kind of reaching out, and whoever was willing to send product got to be part of the research.
And the goal was that you get the products out there, different people that are selling the products who they're helping out. But it was the idea of having our MnDOT crews do the patching. So again, they're kind of a local district patching effort. It wasn't being professionally done in that sense of the term of the contract.
Right. Yeah, these were supposed to be easy to install, typical quick patches, right? Something that you can go out, put it in as fast as you can, and get it back open to traffic as fast as you can. So, yeah. Yeah.
Is there any patch types, say like cracking, type of stress that the products perform better at than others, or was it more just places of patching in general locations they okay? Like, was it? I'm just curious if in the wheel path versus that or things of that nature.
Yeah. Well, so I mean, the distresses were created in the field, so yeah, I don't know if I can answer that.
Okay. That's okay.
Cool. All right. Yeah.
Perfect. Good morning, everybody. Having a good conference. I think there's over 120 people, you said, Mike. That's good. My name is Dan Swartz. I'm with Asphalt Materials, Inc., based out of Portage, Wisconsin, but that's a Heritage Group company from Indianapolis. Tyler served both as the preventive maintenance chair, but he's also our TAP liaison. So turns out he's also a great setup man for this project. He kind of explained the what we strive to do, and we'll get into that here in just a moment. So all this to say, this is a rumble strip durability project studying centerline rumble strips ground into or milled into new asphalt pavements. So give you a kind of a peek behind the curtain if you want. Tyler did say that we're on task 5, which is the last task for this project. One of the promised deliverables, aside from a 200-page final report with 1 million charts and data points and everything, was sort of a best practices guide, if you want. And I think the way we've kind of evolved over this project, what we decided to do was produce, and I apologize for those listening online, but one of the advantages of being here is not only seeing me, but seeing what I'm holding up. We've produced like a single page, just a single one-sided
sort of summary of the project. There's a QR code to the different project reports and so forth on it. So all of the data and everything is easily accessible, but it's something that you can take and kind of distill out a lot of information onto one page. So I put a number of copies on each of these front tables. By all means, take one. The research team is confident enough in where we're at in our research, in the research timeline, that I think this is as final as it's gonna get. But if there is any input on the format or anything, let me know. Right now, they're sort of NRRA branded, but that's kind of less important. So I think I wanted to start here and pull. This is the top half of the document. Is really the impetus for the project. Why did we set out to do this? And I think MnDOT in our literature review, sometime in the late 2000s, so maybe 2008 or so, did publish a report about centerline rumble strip durability. A number of other states have done this as well. And I think it was safe to say at the time when we proposed this project that the jury was sort of out on whether these things actually were a detriment to pavement performance. We know there's safety enhancing benefits. There's no arguing with that. It's a matter of, are we hamstringing ourselves by milling these into a pavement? And then if we are, is there something we can do about it? Or if we really are not, is there something we can do to maybe even fortify the joint further to get even more of these life-saving benefits out of these things? In other words, prolong their functionality. So that's the question we pose. But to be very specific on our objectives, they're listed here. So what we wanted to do is we primarily focused on NRRA states, but we did go nationwide as well to look and see is there something out there that we're missing? Are there recommendations? Are there different design geometries that we need to be aware of? And through that, Tyler already referenced this. What we ended up doing is constructing 3 full-scale projects. So these are we call them county trunk highways in Wisconsin. These are 3 2-lane county trunk highways located from about the middle of Wisconsin, and then 2 of them kind of in the south, one on the Lake Michigan coast and one just about an hour due south of Madison. So these are full-scale projects, all marked 55 that were scheduled for paving, what would have been the 2023 at this point. And the county agencies were good enough to allow us onto these projects to set up both true control sections. In other words, pave this thing how you normally would. We're going to mill in rumble strips to some of it, but then also try some different material treatments. And this is where the cost sharing initiative of NRRA is really a great thing, because we were able to get treatments put on these projects. And then one of the I'd say, not drawback, but one of the variables that we needed to consider in this study is it is focused on short term. In other words, did the milling of the rumble strip do something to the joint when we milled it? We obviously can't evaluate long-term performance before long-term performance happens. We struggled with that in the lab as well in these cores. It's very difficult to lab age field cores of different sizes, different geometries without them distorting in such a way that we weren't comfortable with those results. So it is short-term, but it's predictive, you might say. Then there was a whole nother side of this. There was, do the treatments we select, did they impact the ability of the rumble strip to behave and perform as a rumble strip? We called that functionality in this study. In other words, is the driver alerting noise, internal noise, affected by these material treatments? And then is the external noise, so in urban environments, things like nuisance noise, people call it noise pollution, whatever you want to call it, is a big deal for centerline rumble strips. And we actually heard those complaints while we were on these projects at times as residents, really quite upset that we put them there. But so that's not the problem with the research project. So we measured internal noise. We hired a contractor to hire internal noise and external noise. Some of you that are adjacent to this industry or in this industry, there was an NCHRP study, and forgive me, I think it's like 1104. I don't remember the exact report title that came out last summer that details a method to measure functionality of rumble strips. That's the same contractor we used on this project. We brought them in to evaluate functionality. And then of course so what's the outcome? Well, what can we recommend to our NRRA partners and then the industry at large, if indeed there's something we can do better and use more of these things with reliability. I'm sure I mentioned it, but so all centerline rumble strips in this instance milled over a longitudinal construction joint. All right, we didn't do shoulder rumble strips or anything like that. And these were rumble strips milled really as soon after the second paving pass was completed. So it was milled into brand new asphalt pavement. I promised myself I would get the word sinusoidal in this presentation. One of the projects was sinusoidal. The other two were what Wistock calls standard geometry, which are paired corrugations. Sinusoidal just makes me sound smarter than I am. I use it whenever I can. Probably little relevance to this group. All this to say is the project is pretty well wrapped, even though it was an 18-month timeline from initiation. But what is of relevance to this group, rather than bore you or swamp you, especially if you're not in the asphalt side of things, Lauren's been great helping us get all of our task reports uploaded in the right spot. So on the project webpage where that QR code will take you, underneath the individual tasks are summaries of each task. And then at the very bottom, and a thank you to our TAP members, but at the very bottom is the standalone functionality report. In other words, the report that contractor generated for us, kind of unedited. That's where it was. So anything you could need from this project, anything I'm going to show you for that matter, is on that website, NRRA page. But I would be remiss if I didn't spend some time looking at charts and talking about data, given the crowd that we've gathered here. So this is a busy slide, but we're going to take our time and walk through it. I don't know if I have a pointer. Maybe I do have a pointer. That would be tremendous, but I don't think I do. That's just a prop. You can see here. No, that's okay. We'll go through it this way. So what we've got in both of these charts, when we use the word control on the left-hand side of these charts, what we mean is they did not have rumble strips. When we use the word CRLS, it means that they had rumble strips built in. We chose two different material treatments. One of them, VRAM, which is a void-reducing asphalt membrane, is applied before you construct the pavement. In other words, it goes underneath the intended location of the joint. The other one, rapid penetrating emulsion, is an asphalt emulsion fog seal that goes on top of the joint. So it's sort of a tale of two treatments, one before construction, one after. We tried them both independently, and then we tried them in combination together on that joint. So that's what VRAM and RPE signify. They are very different products, not the point of this presentation, but selected both because of cost share initiatives, but because they are different products. One goes before, one goes after. One of the challenges that we have as an industry is trying to understand. We are well aware that density drives performance in asphalt pavements as constructed. It's very difficult to get an understanding of density at the joint. We can do joint adjacent fairly simply with nuclear methods and so forth, but unless you core the exact location of the joint and measure that, it's difficult. And that's what we're seeing here. Is these are actual cored materials and GMMs associated with breaking those cores down, recoating, and measuring the GMM. I show all this just to say that these material treatments are measurable, right? We measure their effects just via GMM as they drive asphalt content one way or another. It's also a way we can understand variability. But if we look at what's usually the specified parameter for asphalt pavements is air void content. And I put a red dashed line on here at 7% air voids, not as a target, but to show that's typically where, if you were doing a controlled laboratory study with asphalt, where you would target an air void content to. And you can see one of our projects, the Rock County project, hovers near that 7% voids. But the other one's really, in some instances, quite higher, but generally higher. So this is a challenge that we had, is how do we take our fairly good understanding of laboratory testing of produced specimens and apply it to field cores that have all of the wonders of field core variability built into it. But one nice thing that we noticed when we look at this data set in particular is there's a wide enough spread. And I don't want to use the word quality loosely here, but there's a wide enough spread in this to suggest we should see some differences just due to the different construction parameters, mix design, and so forth,
in the air void content. So we feel confident that we were able to gather a wide enough range of data. It wasn't just the same project 3 times. It was 3 very different projects. And they were purposely selected in a geographical manner to do that. One of them was granite, one of them was more of a natural gravel, and one of them was a true limestone type of mix. And I should have mentioned, but I'll mention now, at the county level in Wisconsin, and even at the DOT level, aside from SMA stuff, we make our mixtures fairly fine graded, actually quite fine graded. Minnesota, less so, but still generally fine graded, and Michigan generally fine graded, SMA aside. So these are all fine, dense graded, super paved type mixtures that we use. Somewhere in that, bread and butter type wrap amounts, 20% thereabouts. So very standard paving type mixtures. The lighting in this room is poor. Otherwise, this photo would be that much more dramatic. But we measured permeability was one of the tests we used. We did ideal CT, mostly because of its widespread use among agencies in the United States anyway. We did all of the non-destructive things like air voids and asphalt content, gradation, and so forth. But one of the tests that we selected was a modified version of the Texas Overlay Tester. Not necessarily because of its widespread use, but because of its simulation of what's happening at a joint in the field. So this is a side view of a rumble strip sample mounted to a Texas Overlay Tester plate. One plate moves, the other doesn't. So it sort of simulates kind of like, you would say, like a fatigue type of loading at that joint. Remember, longitudinal joints in general are not driven on purpose, right? Or at least incidentally they are driven on, but they're not loaded in that way. So we're not expecting load-related type failures a lot of time. It's fatigue type of or movement-related type of failures. And what I'm showing here, one of the parameters of the 2 that you get from the Texas Overlay Tester is what's called the crack progression rate. And what that is it's an indication of how quickly a crack that you initiate with the test moves through the sample. And I drew a red arrow here pointing to the crack that's actually propagating through this part, or has propagated through this particular spent sample. Generally, you would think, just like conceptually, if a crack forms, you would want it to propagate very slowly, right? That would be an ideal response. And what we actually found, probably the most significant thing that we found from the performance testing point of view of this study, was that rumble strips statistically did increase crack propagation rate. What that means is, after milling of rumble strips, we would expect if a crack were to be there or were to form there, it would progress through that joint faster at a higher rate than on a control. So that's a negative thing. It's not to say that the rumble strip caused the crack. It's to say that if a crack is there, it's going to propagate faster. On our brochure that we're handing out, it calculates out for the 3 projects we did that the rumble strips cause about a 34% increase on average for a crack propagation rate relative to control. So it's quite significant. Obviously varying degrees based on the project, but as expected, these were different mix designs, different climates, and so forth. What can be done about it? So again, this, let me step back. I apologize. Let me step back. This particular slide is just control sections. So no treatments at all. Just county construct your pavement, and we're going to mill some rumble strips into it and test them. This particular slide is showing the same parameter, crack propagation rate, just different book for each project. Is that, again, we want to lower our crack propagation rate. And what we found is that the VRAM in particular was very effective in doing that. If any of you have experience with VRAM, what it is it's a high application rate of a polymerized binder. That's kind of a seam between the 2 joints that helps these joints stay together. So what we're kind of doing, if we think this is a non-load related type of failure, this crack is having a very hard time propagating through a thick layer of polymer modified asphalt. That makes some sense that would be the case. So sort of like a validation of what we're seeing. The rapid penetrating emulsion, less effective
at reducing. In fact, statistically not effective at reducing crack propagation rate. The RPE is applied at a much lower dosage rate. It's not polymer modified. It's also from the top down. Maybe that matters as well. We don't exactly know. Point being is the VRAM was much more effective when used for crack propagation rate. The bottom half of this handout is, we thought it would just be kind of like provocative, if you want, of doing this as sort of like a fact or fiction, like just ask a question, answer the question, but based around the objectives of the project. And we've got questions and answers listed here, but the key findings that are to follow. But effectively, what we found is that, look, milling of rumble strips in a brand new asphalt pavement actually didn't cause aggregate degradation at the joint. When we measured gradation, it was the same whether you milled rumble strips or you didn't. Kind of interesting. Milling of the rumble strips did not increase permeability. We'll just say that the 3 fine graded projects that we built, none of them would have been considered, quote, permeable based on like conventional limits of like 100 or 125 10 to the minus 5 units. And I'm referring to like the Florida method, where it's in a little case in the lab. So baseline, none of them were that permeable. They'd be considered impermeable. Milling the rumble strips didn't make them permeable. These treatments further lowered permeability, but to say like I made an impermeable mix more impermeable, I mean, you have to decide the value in that. Cracking susceptibility, the number one takeaway that we would present to agencies, and I think we've done in our meetings, is what this study really highlighted was that to get a good joint, you need to construct a good joint. Rumble strips are not the boogeyman of the joint. Poor construction practice is the boogeyman of the joint. If you mill rumble strips into a bad joint, rumble strips are going to cause a problem, but that joint would have been a problem anyway. So build a good joint, mill rumble strips, and you're likely going to be in pretty good shape. However, we did find that crack propagation rate forever, rumble strips can influence joint durability parameters. How that will manifest in future years, are we going to see that? Remains to be seen, but it's predicted that that's what would happen. I mean, we can mitigate that. We have shown that at least one of the material treatments, if not the combination, can mitigate that. Actually, bring it to a level above the controls. And then, last but not least, I mentioned in the onset, and I'll mention here, what about functionality? Do these still serve as safety tools? One of the things that this NCHRP study that was published this last summer did point out is that for certain rumble strip geometries, chip sealing them even one time can change the geometry to a degree that they'll actually fall below thresholds that are deemed acceptable for warning a driver of lane departure. I'm not here to say don't chip seal your rumble strips. What I'm here to say is pay careful attention to the geometry of the rumble strip you intend or you have versus the size of the aggregates that you're using for chip seal. Are you actually achieving a single chip seal layer and so forth? For this project, we didn't use chip seal, but for these 2 material treatments, we found that no, indeed, we didn't change the geometry of these rumble strips. One reason, VRAM is below the pavement. There's no way it changed the rumble strip. And then RPE is such a low application rate, it didn't have an effect on the geometry. And the testing showed that internal noise increment on and off the rumble strip was maintained. Interestingly, and I'm not, I've done a little bit of noise work, not a terrible amount, is that we did find that in these instances that these treatments actually lowered external noise increment. In other words, they lowered the difference between being off and on the strip that the public would hear. And there's some research into that. Asphalt's a fairly good insulator for sound. We did change the density of these. So we didn't try to explain exactly why, other than to show that the measurements indeed show that these treatments may reduce external noise if that's a concern to folks. And the bottom line is as shown here. I don't need to read it to you. Good in is good out. These next 2 slides, just 6 bullet points, really summarizing exactly what we had just walked through. So no real reason to labor through these anymore.
other than to say, you know, the amount of binder content that you're adding for the VRAM really seems to be the driver of the Y component. Why did one work so much better than the other? That's shown here. And then I didn't show any ideal CT results, but you can dig through the report and certainly find me after if you're interested. But one of the issues that we have with the ideal CT is testing over a joint. You can imagine, for those of you who have run that test, it's an indirect tensile test of a core. And we line the joint up with the loading head. The joint is this massive discontinuity in the mix, right? It's the dynamics of loading an indirect tensile right at that point are complex, to say the least. That test suffers from variability in sample production to begin with, let alone introducing a joint. And what we found is the presence of the joint during that test just overwhelmed it. So even when we deconstructed the test and we said, what about peak load? What about post-peak slope? What about energy? In other words, area under the curve. There was no real good indicator of like, I got it. It was just that was the incorrect test to be using. But nevertheless, it's a fast test. It's one that's being implemented, so we chose to include it. But what we found is that the joint behavior really just governed that test. And then again, we can't stress enough what we learned is that really a high quality joint is of the utmost importance. These treatments can help, but they're not going to be a safety. Think of them as insurance. Maybe that's the best way, is that they can help prolong life, but they're not going to create life that's not already there. Project page here is if you'd like, email my contact. I'll be floating around anyway. Partners in this, we use Heritage Research Group, and then Banking Materials out of Beloit, Wisconsin helped quite a bit. And obviously, thanks to the NRRA. Are there any questions I can help with? Again, pick these up. Hot off the press, there's only like 50 copies. So if you're one of the lucky few, I can sign it for you if you want to, but no, just kidding. Yes, sir. Yeah, we collected plant mix for all of these projects, and we built calibration curves at different air void contents. And we found that because these were cores taken days before open to traffic, that's as good as we were going to be able to do. Plant mix, cores, both short term, calibrate for air void content and try and, like you could say, correct for it. That's how we did it. Casey? Do you want to come out? You get your picture with me if you want. That's going to cost you, but yeah. Appreciate it. Anything? Yeah. That's been something that. Sure. If often, well, not often. When we use VRAM, we see VRAM used. Nuclear density is typically waived. And the reason that you would waive that is what our findings here show, and what you would find is that these cores typically have somewhere around 2 to 3% more binder than the surrounding mix would have. And for those of us that work in that industry of density and so forth, asphalt content and GMM are strongly correlated. And if you don't know the binder content, it's unknown because of how much VRAM you put there. You don't know what its effect on GMM would be, and therefore you don't know what your target for the nuke density meter would have. So in other words, not changing the GMM in the nuke meter and then going over a VRAM section would give you a result that's nonsense. You don't know what it could possibly be. So what we do is we'll take a core, and that core will typically have a relatively thick layer of VRAM at the bottom. But to get a GMM of the mix, we'll break it down in an oven as gently as we can. So maybe call it 230, 250 Fahrenheit or so. And we'll gently remix it, and then we'll measure a GMM with dryback of that. So that's what you're seeing here. This is a dryback method GMM of the core recombined. That's how we would do it. I'm not suggesting do that and then go out and run a nuke meter. I'm saying if you want to know the air void content, that's how you need to do it. Or just
or just trust that, it's there.
Leaving the cut faces on it. Well, the core is, right? So when I say remix it, I'm recoding the best I can. Yeah, if that answer you. And then we do a dry back because you're just not going to be perfect. Sounds good. Thank you.
Good morning. Good morning. My name is Emil Bautista. I'm with MnDOT, the Office of Material and Road Research. And I'm working on sustainability and our EPD collection program. And I'm here to talk about our low carbon materials working group for NRRA. These are the members so far that have shown interest. We have a website and there's the QR code. Thank you to all of them for your interest. We are trying to find a way to move forward with this, but as we know, the application came out. They were supposed to let us know in September. They didn't. They let us know in November, and then by the time we had this money obligated and awarded, we were not able to, at least us, complete the grant agreement, the signature of the grant agreement. But this is something that we work. A lot of states that I have talked to here have worked on this. They applied, so I'm hoping that also they could share some of where they are at with this. So our intention was to use these funds to implement EPDs, training and knowledge building, procure EPDs, manage and organize those EPDs, and do any type of advanced testing that we needed to do, which I have talked to other DOTs were kind of the things they were thinking also as well. We met with FHWA division on September 16. Everything was looking well. We had document pretty much ready. They make some comments to correct. We correct them. Met again on January 10th, but from January 10th to January 20th, this came out. I'm not expecting anybody to read, but it's an executive order that terminated the Green New Deal. Some people have told me that the Green New Deal doesn't exist. I have no clue of that. Also, it's very important. What this did is they asked all agencies to immediately pause any funds appropriation through IRA or IIJA, which the funds for the LCTM were from IRA, if I'm not mistaken. And what they asked was that the head of the agency pause this in 90 days. They will submit a report with details of the finding of this review, including recommendations to enhance their alignment with their policy in Section 2, which is above, obviously, Section 7. But by the time you get to Section 7, you forget exactly what Section 2 had. And they had a lot of language on electric vehicles. They seem to, have some issues with that. And that's what you could read there. There wasn't anything related to materials or anything like that. But for the meantime, federally, we got stopped. We got paused. But in MnDOT at Minnesota, we do have legislation. We have a state mandate that is requiring us to collect information on our environmental impacts of materials. We have goals. And we also have an environmental task force that was created to provide recommendations to the commissioner to implement this program by January 15, 2028. We have some eligible materials, the typical materials, and also some eligible projects. And what we're trying to do here is just to start procuring EPDs. That's where we are at, because, again, we have a state mandate. Some other states don't, so that makes it different for them. But we are currently developing some sort of policy and special provision. I'm working with Maria Maston. We're looking at completing that in the next week or two to start kind of going through the process of submitting that. And hopefully by September, there's something that can be incorporated into our lettings for projects next year. We're still defining which will be the minimum quantities of these materials where EPDs will need to be supplied. And also this on the right are our bid items that we're going to be looking at: carbon steel, structural steel. You can see concrete there, and also asphalt mixtures. Then, the other part is organizing this. There's a lot of efforts that were started to, come up with this thought of this money coming, which I think now that the money went away, at least for now, it's paused. This conversation kind of stopped, and only a few DOTs that were able to get this money awarded at having this type of conversation. But we are looking at, what type of database We know industry has some, concerns about sharing the proprietary data. So we're looking at all of these things. And also, I think Rebecca mentioned yesterday about beta and having a space to collect EPD information as well. So that's where we are in the state. As I, started looking at people here and talking to people here, I had the chance to talk to a few DOTs. And I'm actually wanting them to share some of their thoughts and where they are at. I had the chance to talk to Mike. He's the first one here. So can you share with us where your DOT is at? You are Idaho. You guys did apply. Okay. Eric, we talked a little bit too with Wisconsin DOT. You guys were one of the few DOTs, I think out of 5 DOTs that got the funding. What I have seen from other DOTs is they are very scared to spend the money. And the one that have spent it has spent very little just to make sure that they can get that little back. Would you explain where Wisconsin is at?
So the deadlines are going to change, but we're really not proceeding just like MnDOT or Idaho is. We got the agreement signed. About it.
Aaron, North Dakota DOT, we talked yesterday too.
Where that's anchored and just I think, yes, in my opinion, though, with this, I think a big part of this, when we're putting the team together, was really so all these states were in unison. As we kind of went through this LCTM, right? And I think with that being done, that really makes it tough. With that being said, I think these things still come back. I know we're on hold right now, but you never know what the game is. I think there's a lot of work to do on this topic. Back with something maybe not in LCTM, but I think we could press be stewards of this and still kind of keep up with some of the states that do have some legislation. Not first we have to let's learn from what states could look at this and say come back and go just pull your eyes to it. It's going to go away. It's right.
Good, thank you. And Chris, we talked as well too. Do you want to share some of your thoughts, or I think they were very similar to the others? Good, and I think I know there's others DOT. I didn't have the chance. Nebraska, you guys applied? You guys got it now, okay? And Montana, I think, is also here too.
Yeah.
You guys want to share? The same, right? So that's where I'm kind of looking as I talk to others. I am part of a small group of DOTs that have state mandates, and we are talking. They're definitely moving forward. California is way ahead. Colorado is requesting now. And also Oregon too have a deadline to start getting information for 2026. Do you want to share some information? California, hi. Yeah. Yeah. Yes. Yeah. Yeah, and I know you guys are way ahead than the others. I'm meeting Dominica, I think is her name. She's going to show some of us DOTs that have state mandate how your system work and how you guys collect EPD. So that's really, it's going to be good for us to see. But yeah, that was really cool to see. She showed us just kind of a preview, but we want to see more because we are kind of looking at what type of system we use to collect this information too. But just, I kind of wanted to take the time also to, it's definitely, I'm interested in the working group and getting it going, but there's this challenge in which we are imposed by the federal government. That was kind of the motivation to create this group. When Ben and I was starting to talk about this at the beginning, trying to use NRRA as a pool fund that is already established and has so many DOTs in, was going to be beneficial for us to look at, are there ways that we could put this money together, like for training? Why do we have 50 different trainings? We can have just one and it can, go around. Why do we have to have different databases? So some of those things that we were thinking about doing then are now kind of not really clear because everything is on pause. So I guess, also some other things that I see, I think through the teams, we are already dealing with certain parts of low carbon, the concrete sections that we have. We're looking at high RAB. We have been talked about here, recycle binder availability project, which next week we should know that we're meeting Monday to look at that. And the other things as well too. When this came out, Professor Anand Pupala from Texas A&M, he was very interested. He works in the geotechnical area and he had a lot of ideas on low carbon in geotechnical area. So I know there's still ways to talk about this topic within the teams and maybe be chill a little bit because we don't even know what type of terminologies are we supposed to use or not. I know as a DOT Delaware that actually rewrote their grant, eliminated all the language related to sustainability or low carbon and whatnot, and resubmitted the grant to FHWA division. They have heard nothing back, but they did try that. So we're in a time and a spot that we don't really know exactly where we're going. So I guess my recommendation here is to ask the executive committee and executive director to maybe pause this for some time. Hopefully we hear something soon that can give us the confidence and the trust of, can we pursue this, or maybe we should change it and adjust it in the way that the new administration will adjust things. That's all I really have. If you guys have questions or comments, any other DOTs that wasn't able to talk, please share.
All right, I just wanted to kind of add to kind of finish up here in the conferences. It's really fun to watch how NRRA was really designed around the fact that participation, connections are so important, and we're doing that. I think as we've gone through these different presentations, it really does show how we pull together. And again, thank you for all your efforts. I just wanted to touch upon again that Maria, you've been so valuable to us and the research that we've been doing. She's our #1 customer for our kind of research group at MnDOT, along with other specialty offices. But I really loved your enthusiasm, and this whole low concrete stuff was really, your fingerprints are all over it. So thank you for that. And when you talk about Lev usually sits over there now. Okay. Again, Lev has been so consistent for so many years, being really a driver in concrete pavements, and also such a valuable friend. So again, thank you. Well-deserved award. So again, we should be proud of the groups that we've gotten together. How we've kind of pulled together the different intelligent construction, how we had so many different associates and their enthusiasm to the work that we've done. I want to say thank you to the team leads. You got to go through a lot of different things. We kind of wonder if monthly meetings is too much, not enough. You can go back and forth a lot of different ways on that. But again, we should be proud of the projects that we've done, projects we've been able to accomplish, and kind of doing these things on kind of a group effort instead of doing individual states on these same topics that typically kind of is done sometimes in the past. Talking about phase 3, it kind of surprised me the other day. I looked and said, geez, next year is phase 3. So we'll be talking more about that. We talked about that at the executive committee, kind of how that's going to be formed up. MnDOT has a process to be a lead state. This June, we're going to be putting a proposal together for putting a solicitation on the website. Once that gets done, come July, we should have that out. So that's when states show their interest in it. You guys have your own meetings and timings of that. But we hopefully by next, February, we have phase 3 up and running. And kind of looking in the crystal ball too, if we get that running, there'll be more opportunities for projects and things like that. So that'll probably be the next round of projects, and then we go for another round. So hopefully that all works. Again, lots of partnership opportunities, things that we're working on. And also MnRoad does have space to do construction. We're kind of developing a process. This June, we're trying to get ideas put together for the low volume road. Then we'll kind of talk about the main line, different things that we can do in the future. So wrapping this up, we do have the tour this afternoon. I hope that you all can make it out there. We'll make it worth your while. At least you're going to get your steps in because you got a 1 mile walk to do. And you're going to have lunch here. And once you get your lunch, make sure you're wearing your good shoes if you're coming out there. If you have a vest, bring it. If you don't have a vest, we'll find you one. But we're going to be walking down the low volume road. We're going to kind of follow these arrows. There won't be arrows on the road, so you can't follow those. But you'll walk. Bernard's going to talk about his early opening to concrete. We're going to have Jaron talk about water repellency. Any other people that want to be at these sites, maybe you want to be at the water repellency per se. Walk across spray rejuvenators. Joseph will kind of help you out with that. Walk across, talk about recycled unbound bases with Raul. Cross back over. Mike Wallace is not going to be here, but Tom Burnham will be there, and he'll talk a little bit about those concrete sections. Jump across, and Michael Vrtis will be there talking about the reflective cracking study that we have for Low Volume Road. This goes in hand with the one we did on the main line. Then kind of finalizing up again with Tom again, talking about fibers and concrete overlays. You'll come back across, then we'll have some demos in the parking lot too. We're going to meet in the lower parking lot. So when you come to MnRoad, park your car, walk down the stairs to the lower parking lot in the back or in the front. It's kind of like if you have a cabin, you're not sure if it's who's the front yard and the backyard. So track side versus parking lot side, go to the track side. We'll have some snacks there and different things. We do have a shuttle, about 22-person shuttle that'll be driving you down to the end. So don't drive your cars out there. And we'll do a couple different things. So just kind of walk on your own pace. The idea is make sure you end up to the east so you get done with the tour. That's the hardest part of it. Just go east. So with that, don't believe I have anything else. Again, thank you so much for your time, your travels, and all of that you've done with NRRA. So again, thank you.